of grasshopper, it was found higher in Gujarat, and Helicor armigera again, it was found high in Rajasthan. And fall armyworm was observed only in Maharashtra, followed by Haryana. 8.89% armyworm damage was observed in Aurangabad field, in Maharashtra fields. Next. This is the district or block-wise insect pest situation on farmers' field in 12 minutes in Gujarat. The major pockets, that is Bhavnagar, Morbi, Kutch, Banaskantha, Anand, Surendranagar, Kheda, were surveyed. These are some of the photographs of field survey. Here we can see that shoot fly, stem borer, Helicor armigera were the major insect pests. Next. This is the block-wise situation of insect pest incidents in Rajasthan. The survey was carried out in Bharatpur, Churu, Dausa, Jaipur, Jhunjhunu, Karoli, Nagaur and Sikar. These were the situations of shoot fly, stem borer, white grub, termite, Helicor armigera and grasshopper. The photographs were surveyed by Jhumar Lal, entomologist from Fatehpur Shekhawati, of taking the observations in the field. Next. Then district-wise insect pest situation in Haryana was also carried out, and it was the survey was carried out in Jhajjar, Mahendragarh and Rewari. Here we can see that stem borer, Helicor armigera and fall armyworm was the major insect pest at farmers' field. Stem borer was found highest in Jhajjar, Helicor armigera was higher in Mahendragarh, and fall armyworm was again highest in Jhajjar. The press note has been shared by Dr. Surendra Yadav from Hisar about the Helicor armigera incident havoc in Haryana state. Next. This is again shared by the entomologist from Hisar for the Helicor armigera. Next. These are some of the photographs of insect pest incidents in Aurangabad in Maharashtra. Next. So looking to the Helicor armigera havoc during last 2 to 3 years, we have started one experiment, that is management of earworm Helicor armigera in 12 metrochemical insecticides. This is the very first year, and the significant finding was the spray of amantine benzoate 0.002% recorded lowest larval population after 24 hours, 3 days and 7 days of spray, and as well as it recorded highest grain and fodder yield along with ICBR. The other treatments were before, one before. The other treatments were spinosad, indoxacar, chlorantraniliprole and levrocellothrine were found also effective along with this amantine benzoate. Next. This is a survey of insect pest of summer pollinate on farmers' field. In Gujarat, nowadays, summer cultivation is also increasing day by day. So looking to that, we are also conducting the survey in Gujarat. 138 fields of Gujarat were surveyed by Anand and Jamnagar Center, and the incidence of shoot fly, stem borer, helicorpa, grey wheel and fall armyworm was observed during the summer season. However, the incidence was very, very low of these pests. Next. Then storage trial also is being conducted at different locations, that is relative susceptibility of culprit varieties and hybrids to Travelum castanium and Azopatha dominica in storage. At Jamnagar, PP 1705 and MP MS21 were found promising against Travelum species at Jamnagar. In Anand, these were the varieties which were found promising. Next. At Anantapur, these entries underlined with red letters were found promising. At Mandor, MP612 was found promising. At Jaipur, trial conducted but data not supplied. Next. Then, looking to the fall armyworm havoc during the last few years in maize and sorghum, then we are also keeping the watch on this fall armyworm. Monitoring of fall armyworm, that is Spotoptera frugipeda, in Kharif fulminate through pheromone traps. Here, Jamnagar, Anand, Jaipur, Jodhpur, Fatehpur Shekhawati and Aurangabad, all the centers were installed the pheromone traps for the monitoring of fall armyworm. But among these locations, only Jamnagar and Aurangabad center found the adults of the fall armyworm, whereas at rest of the centers, these adults were not observed, and the incidence was not observed. Next. Anthology program for 24-25. Next. From experiment number 1 to 8 will be continued as such, and one new trial has been proposed for the next year. Next. The trial is management of insect pest complex of fall millet through seed treatment and foliar application of biopesticide. This is a new trial. Objective and target is to test the effect of seed treatment and biopesticide against pest complex of fall millet, that is shoot fly, stem borer, Helicor armigera, grasshopper, grey wheel, fall armyworm, white grub and termite. The locations will be Jamnagar, Anand, Jaipur, Mandore, Fatehpur Shekhawati and Aurangabad. Total 9 treatments will be there. Next. In the treatment, seed treatment of imidacloprid 600 fl at the rate of 8.75 ml per kg will be given in all the treatments except control, whereas rest of the treatments 2 sprays will be given, that is application of first spray of insecticides of biopesticides at 30 DAG and application of second spray at year stage. In treatment number 1, 2, 3 and 4, Beauveria bassiana will be sprayed at 30 DAG. And in treatment number 1, it will be followed by azithromycin. In treatment number 2, it will be followed by neem seed kernel extract 5%. In treatment number 3, it will be followed by neem oil 3% spray. And treatment number 4, again it will be sprayed by Beauveria bassiana. In treatment number 5, azithromycin followed by azithromycin. Treatment number 6, neem seed kernel extract followed by neem seed kernel extract. Treatment number 7, neem oil spray will be followed by neem oil spray. And treatment number 8, that is standard check, seed treatment of imidacloprid 600 fl at the rate of 8.75 ml per kg plus spray of imidacloprid 17.8 SL 0.09% at 35 DAG. That is the standard check. Liquid soap 10 ml per 10 liters of water will be used as a surfactant in neem oil 3% treatment. Next. These are the observations of all the pests. Next. So this was all about technology results for 23-24 and plan of work 24-25. Thank you, sir.
Thank you, Dr. Shekhawat, for the presentation. And hello. One or two observations. You have from your presentation, you have to make very clearly. You have written that pests of for millet. So you clearly first slide itself you have written all 12 pests you have written. So you write which are the major and minor one. All the 12 cannot be major pests. So that first slide, so we are not able to understand which is major one, which is minor one. We can get it right there. Yeah, that you have to do it. And then also you second point is that you make it clear that which are the hot spots for the different pests.
Yeah, in log-wise situations we have given which district was higher in which pest. That is there in the red letter.
Then some of the centers here identified, so regular center plus volunteer centers.
Yeah.
Which are the centers for hotspot for which pest? Those things should be very, you can make it very clear. And you have written one another thing, third point is that you have screened 106 lands and the second one is 32 lands are advanced lands. So 106 lands are germplasm or which lands?
Initial line.
Initial IVT entries.
Initial line.
I see. Okay, then you are evaluating, of course, the co-chairman will comment on that one. So you are evaluating the screening the pest for at vegetative stage and as irrigated stage. You 2 stages you have written.
Yeah,
is it the method or any other method is there for sorghum and other crops where you are screening the pest for it at different 4 stages? So in per minute I can see you have written only 2 stages. That is one clarification you can clarify.
Okay, in per minute we are recording the observations at 20 DSG for vegetative stage because at that time fruit fly incidence is highest at that time.
That's okay, but it is not clear. So you have written only vegetative, which how many days those things are not clear.
We are recording.
You should make it very clear that one.
Okay, sure.
And one more thing is that very good your experiments are there only on this surveys and other things. Many surveys have been carried out in many centers. That's a good thing and very good progress on the survey other things. But actually experiments are very less. In your technical program, I can see many experiments are formulated, but actually the experiment result, experiments whatever in the last year, only 1 or 2 have shown. So it is as per the technical program only.
Yeah.
So these are some of my comments, and if there are any, and I will hand over the mic to co-chairman for further comments.
Thank you, sir. So excellent presentation, sir. But one or two points. So you have screened some of the entries against shoot fly, but you have not mentioned what is the basis for resistance. Suppose you have identified one line which is resistant against shoot fly.
Resistance means 0%, free from shoot fly.
Maybe it may be 0 or 1%. But my question is, so what is the basis for that resistance? Have you studied any biophysical or biochemical parameters?
No.
That has to be studied. that is the scientific way of presenting the data. So without any basis, we cannot say this is resistant based on field screening. So we need to evaluate further in artificially releasing the insects, and you have to confirm the resistance at your laboratory, and also you have to study what are the biochemical parameters or biophysical parameters which are attributing for the resistance. So then only it will be a scientific study. So just like a layman, we cannot say it is resistant based on the percent damage. So that is my observation. So please take care of those things. And another thing is you have formulated one trial against Helicobacter. So with the different insecticides. But the dosage of emamectin benzoate, you presented that emamectin benzoate is effective against Helicobacter. But the dosage is 0.002%. So what is the dose per liter?
3 gram per 10 liter.
No,
0.3 gram.
No. It won't come like that because it is 5% Sg. So you are saying 0.002%. 0.002 into 1000 divided by 5. What is the dose? It comes to only 0.05 grams. It is not correct. So it is 0.4 grams or 0.5 grams maximum.
Actually, I have kept as per the CAB guidelines. For gram per water, they are...
No. It may be correct in your sense. But my question is, when you mention percent doses, so you think of how do you calculate the dose per liter? So 0.0002%. That is very low dose. 0.002% means, so 0.002 divided by the strength of the formulation, 5% Sg into 1000. So you calculate what is the dose per liter. So you are saying 3 grams. It won't come 3 grams. You think of all the doses you have mentioned in percentages.
Actually,
so it is not correct.
It has been taken from the CAB guidelines for the gram per water.
Whatever it may be, sir. Any guidelines you may be following. But calculation of doses is it is a standard. So another thing is you have given the shoot fly incidents at different places. So you are saying the shoot fly is the major problem in all the areas. Okay. So what about stem borer? Stem borer also earlier we used to say the major pests are shoot fly followed by stem borer. But what about the stem borer? So as our chairman said, rightly said, you have to categorize the major insect pests and minor insect pests based on the incidence levels at different places. So nowadays, after maize, so the fall armyworm is considered to be major pest on pearl millet as well as sorghum. So you are not focusing your study on fall armyworm. Just you are recording the data of incidents at different locations with respect to the fall armyworm. But you are not focusing the real studies on fall armyworm.
But sir, if we forward the program, then if fall armyworm will not come, then what is the meaning of keeping the program?
Wherever the fall armyworm problem is major, there you have to ask them to formulate the program.
At Aurangabad center, they have the problem. At that place, we can allowed them like that.
What is the time of occurrence of this fall sorghum during Kharif or
Kharif.
Kharif?
But in Gujarat summer also it is being observed now.
Okay. These are my comments, sir. Now I hand over mic to Shah.
Any questions from the audience?
साहब एक मंडोर का इशू है, उसको एक्सपेरिमेंट्स थोड़ा कम करके उनसे बात करके, क्योंकि वो सीसीएम में पहले से ही ना काम कर रही है, एशिया में आपसे काफ़ी सारा वो प्लीज सर एक बार वापस से आप बातचीत करके उनके एक्सपेरिमेंट्स कम करके वो कर देंगे।
मकसूद ना
This is regarding Shutta. Shutta is also a major problem in fulminate. So what is the level of susceptibility in the susceptible sec and resistance in resistant sec? Do we have designated resistant and susceptible secs?
Sir, we don't have a susceptible check as like in pathology there is 7402 S is there, but in entomology we don't find any variety or line that has got 100% damage in the line.
And what is the level of damage in fulminate?
15 to 20%.
Only that much.
15 to 20%, maximum 25%. This is the average incidence range.
How much damage in economic terms it is causing fulminate?
How much?
Damage it is causing in economic terms, if it is avoidable losses, how much it is there?
That
I had any experiment on avoidable yield losses.
Yield losses I have shown, sir. Yield losses around 18%.
18%. But so far we don't have any, in that scale only nothing is defined as resistant and susceptible.
Yeah.
No check is there. I think we should define what is, at least in the given lines, what is resistant, what is damage. Otherwise, you say it is a major test actually, but you don't have any defined time, resistant and susceptible.
Yeah.
Look at this.
Dr. Shokawat, so many points have been raised and suggestions have been given by co-chairman also and PC also. If you don't have resistance and susceptible checks, then there is no meaning in evaluation in phase 2. What is the use of so on?
Yes, this is see, Murali Krishna was also referring to what are the traits actually that make a given line as a resistant line. In sorghum, the traits are very well defined, like trichomes are there, glassiness is there, typical wax is there. So such kind any studies have been done in formulae to indicate that the presence of these traits make a line resistant.
Okay.
So such biochemical, maybe many biochemical. So we are actually in sorghum even probing the volatiles now. Why insects are actually attracted to a susceptible or repelled in a resistant. So such kind of studies are also happening in sorghum. Similar kind, if it is possible, you can look at or even formulate.
We have started one basic work on shoot fly that we are regularly sending the shoot fly samples to Bangalore Center, Dr. Prabhu Ganigar. So he is identifying the species that which species is now damaging this
That is different. That is taxonomy, which species is more prevalent in which location. But what is the mechanism of resistance? See, there are three. One is oviposition. Second one is anti-xenosis and tolerance.
Yeah.
So what are the factors that are making your line as a susceptible? So what are the ones which are making it as a resistant? Otherwise, that probing should happen so that we can define in terms of those names, this line, if this much it is there, it becomes resistant.
Okay.
So like that you have to see it.
So Dr. Shekhar, many suggestions have come and you may please make note of all the points. And for screening other things also, it's very important that you should screen for more germplasm other than so that you identify the resistance checks as well as susceptible checks, and you should include that one. I think you can take the example of sorghum and he'll be presenting. So you go through those sorghum entomology report also. So you will be knowing more things. So many basic questions have been raised and the remedies have also suggested by the co-chair. So you may please note down all those things and improve the program. So next I will call upon Dr. Shetty for sorghum entomology.
Thank you very much, Chair and Co-Chair, and all my respected speakers and audience. I will start presenting the progress report of AACRP on sorghum. And there are 14 centers, and there are 8 centers in Kharif, and for Rabi there are 3 centers, which is given in blue, and we have 3 centers for both Kharif and Rabi across the country. And this is the action taken point, that it is to be to compile the past 5 years data of the sources of resistance against insect pests of millets. Is to be it was a recommendation of the previous AGM, and the data was compiled, and it will be published shortly after inclusion of this 2023 data too. So coming to the major pests of sorghum and their hotspots, we have shoot fly and stem borer as the major pests of sorghum in Kharif. And in addition to this, we have this yellow aphid and shoot bug, and also midge as important pests of Rabi sorghum. So these are the hotspot areas for shoot fly, Parbani, Rahuri, Dharwad, Akola, etc. For stem borer, aphid and shoot bug. And the midge is one important emerging pest. It is coming in very located pockets. It is in Koilpatti, Coimbatore, Disha, Nandyal and Bhavani Sagar. So come to the pest situation in the previous Kharif 2023. This is the situation in different centers. You can see the centers in the down, and the percentage of shoot fly damage, that is dead heart percentage, it ranges from 7.9 to around 32.9 percentage dead heart. And in for stem borer, if you can see, it is from 2.5 to around 33.5. It is in different centers. The least being in Pantnagar and is maximum in Indore. Coming to fall armyworm, this has been recorded in different rating. It is in the scale of rating 1 to 9 in different centers. You can see Dharwad and Indore as hotspots. The rating is very high, 3.6 to 4.4, whereas other centers have less rating. Come to the Rabi sorghum. This is in different 4 centers. The shoot fly and the stem borer damage, how much it has been there. The stem borer especially, it is around 3.2 to 7.1, and the shoot fly it is around 7.9 to 15.7%. And in terms of fall armyworm, you can see that it's really a Rabi season pest. Here you can see the damage rating is from 1 to 9 scale. In Dharwad, it is the maximum of fall armyworm 4.1 in the 1.9 scale. And followed by other centers. So this is the trial summary of Kharif sorghum 2023. These are the trials we have conducted. The first 3 ones are of grain sorghum, and the next 3 are for fodder sorghum. And we have trials for sweet sorghum. We have trials on high biomass sorghum, and also for brown midrib sorghum. Specifically for entomology, we have shoot pest nursery, and also we have a very important nursery, that is shoot fly nursery, that has been derived from F6 derivatives. That is the cross between the resistant genotypes with the elite lines. So it has been tested in the F6 generation. In Rabi, we do have AVHT grain sorghum, IVHT grain sorghum, IHT grain sorghum, and the shoot pest nursery. So come to what the screening what we have done in AVHT, IVHT and IVT. None of the test entries were found tolerant to shoot fly. We have a test entry of resistant for shoot fly. It is IS 2205 resistant check, and Swarna is as a susceptible check. The resistant check gives like a 10% damage in terms of dead hearts, and the susceptible check is 20.8%. With this, we have compared the other lines, and these lines are promising lines. In 3 lines in AVHT GS and 2 lines in IVHT are found tolerant to stem borer and on par with the resistant check IS 2205. Come to the 4A sorghum. Here again the shoot fly screening. None of the entries were found promising in IAVHT MC, but 5 entries are found promising in AVT SC, and 2 in IVHT SC were found tolerant. Here also that IS 18551 is a resistant check and Swarna as a susceptible check. The range of resistant and susceptible check is given there, 21.9, and it is susceptible check. It goes up to 57.4% dead heart by shoot flies. Come to the 4A sorghum, temporar, the 10 lines in IAVHT MC and 7 lines in AVHT SC, that graphs are given down, along with the resistant check and the susceptible check in the last, resistant in red and the susceptible in green. Then come to the sweet sorghum and high biomass or brown midrib sorghum in Kharif 2023. Shoot fly, one of the line was found promising in IAVHT sweet sorghum, and none was found promising in IAVHT high biomass sorghum and brown midrib sorghum. Whereas the temporar, we do have 2 promising lines in IAVHT sweet sorghum and 1 each in high biomass sorghum and one also in brown midrib sorghum. Here also the resistant and susceptible check, the ratings are given in the graph. So come to the next important part, that is shoot pest nursery. In Kharif 2023, the locations, there are 11 locations this trial was conducted, and you can see the shoot fly, there are 3 entries which were on par with the IS 18551, that is the resistant check, which is given in the green, the first graph, and the susceptible check is Varna, which went up to 67.3% of dead heart. So for temporar, the 5 entries, SPV 2886 and others, were found tolerant and which was on par with IS 2205, the resistant check. Come to the different trials. This is one very important trial, that is the F6 derivative, which is derived from the crossing of halide lines with the resistant sources. We have 31 entries. We have tested this along with 3 locations, that is Parbhani, Palam and Dharwad. And here you can see the shoot fly. The damage of susceptible check is up to 69.8. You can see the level of damage, 69.8% shoot fly damage. In that situation, these 3 lines, SF 56, F6 59, SF F66 and others are found tolerant. Madam, you don't do, I will do that. So temporar, in temporar we do have different lines. Here also a resistant and susceptible check is there, and these 12 lines which was given here are found promising. So it will be taken for the next studies. So many a times we feel like shoot fly is not the only one, because we have studied Atrigona succata as the shoot fly of sorghum, but it is not the case every time, because many other shoot fly species are also found damaging this sorghum in different centers. Also, 2 years before we made this arrangement, that the different centers like Akola, Bijapur, Coimbatore, Dharwad, Hisar, Hyderabad, Ludhiana, Pantnagar, Parbhani, Rahuri, Surat and Udaipur. These centers were sending the dead hearts to IAMR so that we could able to rear it, we could able to do the taxonomical studies. What are those species which are affecting that dead heart percentage? So we could able to see there are 3 different species of Atrigona. So 3 different species of Atrigona were found on sorghum in many locations, indicating the involvement of many species. That's what Atrigona succata, though it is predominant, but Atrigona oryzae, Atrigona simplex and Atrigona pulla. These three other than this Atrigona succata were also found in many of the locations. You can see in the graph. And apart from this Atrigona species, there are 2 chlorophyll species also caused shoot damages. So a total of 11 species of flies were found, identified from this disease, dead heart symptoms. So come to this management trials, management of fall armyworm. As everybody knows, fall armyworm is one of the major problem nowadays in sorghum also. So we have formulated a management for fall armyworm with entomofungal pathogens. It has been conducted last 2 years. This year we can have a recommendation on this. So it was conducted in 2022-23 and also in 23-24. I have given the pooled mean here for the world damage and the pooled mean for the grain yield also. You can see there are 7 treatments there, indicating the treatment 1 with Metarhizium anisopliae, Metarhizium raleae, and from different strains. One on IOF1 and another from NBAR the Metarhizium anisoplia, Bavaria bassiana from IOF, and neem-based insecticide, and the insecticidal check, the chlorantraniliprole. So we could, madam, you don't do that, do it.
No, sir.
Okay, it is happening by, okay, fine. So it is like a chlorantraniliprole, this is the insecticidal check, and we have an untreated control too. So though we could able to see that the T6, the insecticidal check, though it has given the best reduction in terms of pearl damage and also in terms of grain yield, we wanted to have a entomofungal pathogen. It's a bio-intensive pest management. So among the entomofungal pathogens, T3, that is the Metarhizium riley of IOF1, sprayed at the rate of 2 gram per liter, was found really very significantly superior in reducing the pearl damage caused by fall armyworm by a tune of 47.9% and increase in grain yield for 38.7% over the control. So this can be go as a recommendation because 2-year studies is completed. Metarhizium riley of IOF1 at the rate of 2 gram per liter can be recommended for the management of fall armyworm in sorghum. So come to the integrated management. Many times the pests will not occur in one isolation. So it will occur in along with the diseases. So what we have done is to integrate the management of pests and diseases together. We found 2 locations in it, and we have tested with a variety of CSV 2027 with this 8 treatments. That is the C treatment with the thiamethoxam, C treatment plus foliar spray of chlorantraniliprole, C treatment plus foliar spray of Metarhizium anisoplia, and many other different treatments. And the 5, 6, and 7 treatments are the lone treatments like foliar spray only of chlorantraniliprole and foliar spray. There is no C treatment. The first 1, 2, 3, and 4 have C treatments in it, and the 8th treatment is controlled. So we could able to see that T4, that is the C treatment with thiamethoxam and foliar spray with the hexaconazole. These 2 are found compatible, so it can reduce the pest and also the disease also. So this is what effective in reducing the shoot fly dead hearts by 46%, stem borer dead hearts by 20%, ergot incidence by 44%, and also the decreased incidence of grain mold also it was noticed. And 27% increase in grain yield is also noticed in this. This particular experiment is done for pests and diseases together. So come to the Rabi sorghum. Till now we were talking about the Kharif sorghum. We have come to the Rabi one, and we have 3 different trials: AVHT, IVHT, and SPN. I have given IS 18551, that is the resistant check, and the Swarna as the susceptible check. You can see the range of damage in the resistant check and the susceptible check, so that we can compare with that all that entries, whatever it is being tested here. So these are the different entries found promising in different trials: AVHT, IVHT, and SPN. So come to the second one. As I told, aphids and shoot bugs are the most and the rising important pests coming in Rabi sorghum. So we have trials on AVT, IVT, and SPN on aphids and shoot bugs too. These are the different entries which are promising. So come to the biorational approaches to combat insect pests in Rabi sorghum. We have 3 centers: Vijaypur and Dharwad and Rahuri. This is the plot size and other things are being given. There are 7 treatments. The first treatment is with the C treatment with the Fortensadio, that is thiamethoxam plus cyantraliprole at the rate 5 ml per kilogram of seed, plus well application of Decanicillum licani and Metarhizium riley. These things are common for treatment 1, 2, and 3. So we have added 1 row of cowpea as a border crop in the treatment 2 along with the treatment 1. So the treatment 1 was done in treatment 3 also. Only changes was with ajwain as a border crop. So you can see the treatment 2, that is the seed treatment and the other things T1 plus the cowpea and plus the neem based insecticide was given in treatment 4. And the treatment 5, it is the same thing. Instead of cowpea, ajwain was added. And the treatment 6 is the standard check, that insecticidal check. The treatment with the Fortensadio at 5 ml per kilogram of seed, followed by foliar spray of cypermethrin at the rate of 0.5 ml per liter, was given as standard check in treatment 6. Treatment 7 is untreated control. You can see the differences in treatment 1, 2, 3, 4, 5 and 6. Though the grain yield was really more on T6, that is 29.1 quintals per hectare, but you can see the treatment 1 itself, that is the treatment was with the potent sodio and the wall application of Liconesidium lucani and Metarhizium anisocliae, could be able to reduce the fall armyworm damage by 37% and dead hearts by 17.6% over the control, with an increase in grain and fodder yield of 27.5% and 31.7% over the control. So unfortunately we were thinking of doing some biorational approaches by introducing a border crop, or we were thinking of doing the neem-based insecticide, and we have done this. But unfortunately, there were no much effect could be able to seen because of that border crop of cowpea or ajwain, and also for neem-based application. But this is the first year data, sir. We will be doing the for one more year to conclude this experiment. So this is about the publications, whatever we have done by the different centers, the national journals, the conferences, popular articles, and other things. So come to the technical program, the last part of my presentation. The first one is on integrated management of insect pests and diseases. That's what I was telling, that two different things have been done with insect pests and the diseases together, which was I was presenting. That will go as a second year trial. And also the biorational approaches to combat the insect pests, just I was presenting, that will also go as a second year trial. Apart from that, we do have evaluation of shoot pest nursery, and that F6 derivatives what has been bred with elite germplasm, elite lines with the resistant germplasm, that also will go. And these are the different screening and in the advanced and initial trials for breeding yield trials against the insect pests of sorghum. And these are the different centers which have been taken, means ABHTGS will be taken by 8 centers, and different things have been given. It has been thoroughly discussed in the center-wise presentations and others. This is the new initiative that resistant lines identified against the shoot fly. During the past 6 years, we have already taken a note of it, and it will be multiplied in this time, and it will be again screened once with this 5 centers in Kharif 2025, so that we can use those lines definitely in the breeding program, so that it will be imparting resistance in our newly released varieties in the coming time. And as I told, midge is an emerging problem, and sometimes last year we could able to see 100% damage due to midge was also recorded in some of the places. So we wanted to have a midge nursery also, which will be initiated by in the centers like Nandyal, Disha, Koilpatti, Bhavani Sagar and Coimbatore. Thank you very much for patient listening.
Thank you, Stanley, for a nice presentation. So some observations are there that even the news here we are seeing in the evaluation part of shoot pests for all the shoot flies, temporary and other things. Like that in I am seeing a very low percentage, less than 35 he is showing all the time. But in our variety identification, some they are showing more than 50%. So there is some small doubt here. I want to Dr. Stanley, could you follow? So this is one question. You may clarify it. And it is good that other than Atharigona saccata, many other species are also identifying, quantifying it, how many are there. So other than Atharigona saccata, other species are also affecting. So that is one thing. And also it's a good thing that there is a recommendation for the management of fall armyworm. That's a good thing. And very interesting that your 2 experiments, particularly integrated management of insect pests. I think this is second year of testing, is it not? So 2 years are over, and one new experiment, that is a biorational approach to combat insect pests.
1 year over.
Only 1 year over. This is a new thing. And another aspect I want to question you. So you have identified so many resistant lines, is it not? So you are saying that for the last 6 years we have identified. So is there any need to again retest them or not? You may clarify. And I also hear the request all the breeders concern that they identified so many resistant plants, new resistant plants have been identified in sorghum for different insect pests, and those should be utilized in the breeding program. So that is not happening. That is the reason why we are getting more than 50% should fly, red heart, those things. That's a really matter of concern. So at least if we restrict up to 40%, then it is a good thing. So that is not happening. So the new sources of resistance should be utilized. And I am very concerned that the midge has come back, and we are mentioning some of the lines, centers. Nandyal, Disa, Koilpatti, Bhavansagar, Coimbatore. Why don't you include Parbhani? Parbhani was the center which worked on midge earlier, and there are a lot of PhD theses are also available there. And the persons who have done PhD on midge in Parbhani, I know them. So that's why Parbhani is a very important center. Why don't you include the center as Parbhani also for scaling? That is Bhavansagar, I don't know, but Koilpatti certainly, Koilpatti and Nandyal, of course, these I don't know, but Coimbatore and you can include Parbhani.
Sure, sir.
So these are some of the points, but my only major concern is that all the resident plants identified by the entomology group should be used by the breeders effectively, so that we can we can see that the should play red heart percentage goes not more than 40%. There's one observation, and for the rest of the comments, I will pass on to Kochi.
Before that, I will tell one thing. This why we wanted to do again is like some 6 years we do have the resistant lines there, but some of the years some lines were not done. So we wanted to pool and check once more. That is the only thing.
It's okay. You want to reconfirm along with the other lines.
With all the resistant lines together in one go.
Yeah.
That's only.
So here I want to that Shekhawati was presenting Parliament address. You can see the report here. So they have got all the resistant susceptible checks, everything he has mentioned in the tables. So we should have those things, and screening should be proper only if we have those things. So Coach Sharma, please.
Thank you, sir. So many observations were pointed out by our chairman. So my observation is Dr. Stanley, very nice presentation. The species apart from Atrigonus succata, you have identified 3 more species. That is very good. So anyhow, Atrigonus succata is the predominant species among all the species. So you have identified resistant lines. Again, you are going for reconfirmation.
Yes, sir.
So before going for reconfirmation, why don't you go for basic studies? Like what is the source of resistance or basis for resistance?
Yes, sir. Exactly as you have pointed, this basic studies we have done already, and which is published also. Based on that only, that resistant and susceptible checks were being made.
So what are the major contributing factors?
Major contributing factor is the vaccinus in the teeth, and also the epicuticular vaccinus and the trichome density.
Okay. What about biochemical aspects?
Yeah, biochemical aspects also was done there 3 years before. I have to really go through it and see what it is exactly.
Yeah, you also go through the biochemical parameters, which is more
resistance to this.
Yeah. So somebody is saying silica is offering resistance in case of millets, silica content. So likewise, you identify what are the biochemical parameters which are offering resistance.
Sure.
Likewise, and also you can go for molecular approaches by involving biotechnology scientists. Okay? So then you have one more thing. With the fall arboretum incidence of 47.9%, you got yield increase of 38.7%. So with less than 50% reduction of the fall here, you can see the increasing grain yield is 38.7%.
Correct, sir. Wow, exactly, very nice critical review on this. The important thing in sorghum, sir, fall arboretum, it affects the sorghum But when there is a incident, when it is the panicle emergent stage, after that we will now never find the Palarmimum incidence in sorghum, sir. Before panicle incident is happening, that time it is affecting the sorghum. The best part of sorghum is after the panicle initiation happens. After that, the Palarmimum incidence is very, very less. It will not be there. That's the.
My question is the reduction of 47.9%.
How will increase in yield?
Increase in yield is very high.
Very high. That is because of this only, sir. It is not affecting the panicle much. It is affecting the leaves. So even with less reduction, we could able to have the increase in yield because it is not affecting the panicles much. Palarmimum.
Okay, another thing is you are reporting that application of metrizum relay, IOF 1 strain, is giving good control when compared to the chlorantraniliprole. So the next best treatment is metrizum relay IOF 1. So what is that IOF 1?
This is actually from the Institute of Organic Farming, which is located in Dharwad, sir. This from them they have isolated this and they were supplying for us treatment. It is from the Institute of Organic Farming, Dharwad, IOF.
What is that formulation, liquid or?
It is a liquid formulation, sir. It's a talc formulation.
Yeah.
Oh, sorry, it is a talc formulation.
Okay, these are some of my observations. Now I request any question from the delegates.
Good morning. Sir, you want to mention the different species of the soap fly affecting different locations. And you have to also mention the longids. Which species of longids is affecting? Because you have to not mention that one.
Yeah, I also don't have data right now.
No, last two years we have to getting these observations.
Okay.
Longids are
No,
there.
no, it is there. It is there. Right now I don't have the data. Actually, I am presenting in place of Dr. Shamprasad. So I will come to you. I will give that data to you, sir.
Because
What are the species?
somewhere the longids have been
Right.
And different species. And I know that foliage is affecting only in maize.
Right.
But in some area it is also affecting on the sorghums.
Thank you very much for that. I will come back to you, sir. I will give that data. What are those species of longids?
Longids.
Yes.
I know that longids are the only scavengers, right?
Right.
But it is affecting only.
Correct. When there is an entry point, it is affecting, sir, normally.
Sometimes, maybe.
Right.
Dr. Samant, please take the mic.
Could not hear, sir. Right.
You mentioned other than Agaricuna Socata, there are other three species affecting, causing damage. How much economic damage they are causing?
Sir, separately we did not study, but 68% is of Agaricuna Socata only. So all other contribute to the other 32% only, right? So whatever it is, the other three species, it is near around 30%. So 70% near around is Agaricuna Socata. But we have to tell that it is also there. That's the only thing. We will be doing, sir. We can do that studies. How much that other species are having damage on this.
Right. Is there any way to find out the way of damage of the other species? How you identify?
No, sir. We ourselves could not identify because these are all denoted as dead hearts only. So we have taken that, the larval taxonomy we have done and we have found that, sir.
Thank you.
In field we could not able to identify it is because of Agaricuna Socata or the Pulla or any other thing.
Dr. Matsulan.
Continuing with Pawan's question actually on species identification, I wanted to ask in other ways, what are the implications for breeding? If we are showing that there are many species are there other than Zagota, should we breed for separately for each species, or if I breed for one resistant variety and it becomes resistant for all things?
This
Not
was
susceptible, it becomes susceptible for all the species.
exactly.
Anything is there like differentials, so that this what we see in pathology.
Exactly, sir. We have to go through that the level of deep studies, because if there are 3 different or 4 different species are there, that too in more than 20%. Then we have to definitely do that.
What is your observation? For example, IS 18551 is not to be resistant.
Correct, sir.
If I put it with all the species, is there any variation in this reaction?
In first go, we could not do any. We could not see any difference in variation, sir. Variation, differential susceptibility or differential resistance, because all the species are attracted towards the same thing, which is susceptible, and all the species are going to the not going to the resistance. So there is no difference at one go. But we cannot blanketly tell that if it is Acacia is resistant, it is resistant to others. That fine-tuned studies we have to do that.
Yeah,
Yes.
that question comes to him also, let him answer in his studies. One more is, we made actually set up, we wanted to have that experiment resistant lens pulling from the earlier studies.
Correct.
And in that you see that any given line is continued for 3 years. Evaluation should happen for 3 years. At the end of 3 years, from the 3 year set, you should delete the ones which are more susceptible.
Correct.
So take only the creamy ones and then continue.
Exactly,
So keep
sir.
on adding like a moving average type analysis. You see that at the end of some years, we should have only the very good resistant lens that should be fed into bleeding programs.
Correct, sir. We have done like that only, sir. We have taken the 3 years one only. But only thing is like some entry. For example, A was resistant
That
in.
is fine. What happened now onwards, you see that any given line is evaluated for 3 years.
Yes, sir. Sure, sure.
Then only you conclude on that.
Exactly. Exactly.
Thank you, Stanley. So before asking Dr. Prabhukanage, I want to know from the PI Surgam or Dr. Matsudana, so what is the status of utilizing the new sources of shoot flare resistance? I think is it in the advanced stage or what? Just I want to know.
So anyway, I was also building for shoot flare resistance in my earlier program. So we have used many new sources of resistance other than IS 1855. So around 20 lines were found to be from the Vinico set. We found 20 lines to be as good as IS 1855, and they are representing different countries also they are there. So those all lines we have used in the breeding program, and now I have around the F5 generation material which has been evaluated last year in the Agri program also at IMR. Those lines are very good actually in their resistance levels. They are as good as IS 18551 and also in high background, this agronomic background. That material this year will be distributed to the centers for the use. Yeah, that is good.
This is very important because yesterday in the VIC, DDG was very particular why it is going more than 50% those things. So here I suggest request all the breeders to use the new sources of resistance and bring down the shoot flare data percentage.
Yes.
So next, thank you. So next I request Dr. Prabhu Ganage to present the entomology of small millets. So you please finish in 12 minutes.
Respected Chairman and Co-Chairman and all the audience, I would like to present the entomology, particularly small millet entomology progress during the 2023 and 24. And here, you know, in the small millets, we have a regular 4 centers we have, and we have other volunteer centers, particularly Dholi, Vagai, and Tiandal. Agri is last year we have included. This year I have included the data for this year. And we have 4 different sections, particularly test surveys, finger blade. At a Dolly center, we have the incidence of shoot fly, very negligible, but shoot fly incidence also observed in finger blade at a Dolly center. Here, 31 entries we have screened against multi-test here in 5 centers, and all tested entries are found to be highly tolerant. And in ABT trial, here total 13 entries were screened against the pests of finger blade at 4 centers, Bengaluru, Barampur, Dolli and Ranchi. Here all 9 entries tested found to be highly tolerant. And in particularly in the Kodo millet, here in Kodo millet initial and advanced varietal trial, in which 12 entries were screened against shoot fly, here in 3 centers particularly, here 2 entries highly tolerant and remaining entries are found to be moderately tolerant. And in little millet, here 21 entries were screened against shoot fly, particularly in 6 centers, and 1 LMV 590 highly tolerant, and others are moderately tolerant, and only 1 entry LMV 595 found to be tolerant. And normally it shoot fly percent ranges from dead heart ranges from 9 to 24%. And in foxtail millet, here 22 entries were screened against shoot fly in 4 centers particularly, and dead heart percentage was ranging from 5 to 16%. And here all the entries were found to be highly tolerant, but except 6 entries were found to be moderately tolerant. And in the proso millet, 13 entries were screened against shoot fly in particularly 5 centers. And here dead heart percentage ranging from 11 to 29%. And among tested all the entries found to moderately tolerant. And except the PMV 490 and PMV 433 found to be tolerant. And in Barnett millet, here 12 entries were screened against shoot fly in 3 centers, particularly Bengaluru, Dolli and Hagri, and dead heart percentage ranging from 6 to 25%, and all the 8 entries found to be highly tolerant, except 4 entries were moderately tolerant. And in brown top millet, here 7 entries were screened, and in 4 centers, particularly the dead heart percentage ranging from 12 to 18%, all the 13 entries were found to be moderately tolerant here. And here in this total overall screening trial, here 145 entries were screened, and overall in the experiment, here 533 germplasms were evaluated during the 2023 and 24. And here in case of shoot fly screening nursery, we have started 2 years back, and among the large scale screening we used to do, among that few susceptible and resistant checks, resistant germplasms were selected to know about the susceptible and also the resistant population in that. In different crops we have made, here promising entries were identified. And here in this last year we have screened in little millet and also brown top millet. Here screening against the shoot fly particularly, we have identified promising germplasms. Particularly this one we would like to do biochemical analysis, whatever sir mentioning regarding, would like to do for particularly susceptible and resistant, particularly for resistant attributes, particularly for phenolic contents, or maybe sucrose content for the susceptible. That characters we would like to know. Maybe next year we may get the data, so that I will present it. And here another thing regarding the management of shoot fly in little millet, we have selected around 7 chemicals in that for the management of shoot fly in little millet. Here in seed treatment also 4 chemicals we have selected, and among that we have found to be in the seed treatment, imidacloprid found to be chlorantraniliprole, and thiamethoxam found to be the best effective for the seed treatment. And also while in case of spraying purpose, particularly imamectin benzoate and thiamethoxam also found to be effective for spraying for the management of shoot fly in little millet. And another regarding geographical distribution of different species of shoot fly, here we have made a different method of collection. Particularly we used to pluck the dead heart plants and bring it to the lab and keep it in a covers with made with holes, so that the adults they can emerge, and next we will process it for the identification. Particularly in the fish meal also we use, particularly in this, only females we used to get, we may not use for the taxonomic studies. Earlier I used to do for the collection purpose is a fish meal, and sweet net is the better one. We can collect for the shoot fly identification, and Malay scrap also we can make so that other species also we can collect, particularly surrounding areas of the millet area. And another very, very important is in this every year from 2016 we are collecting the whole around more than 1,500 specimens we have collected and also pinned in particularly at the Bangalore center, and we have made the identification lab particularly on the not only on the shoot fly, other particularly because we would like to know the characters of the other families. Particularly, we are doing that one, not only this one, agromyzids and syrphids and also other dipterans also we are concentrating. Along with this, we have developed the expertise. And also in this little collection we have made in 2023, overall, all over India we have collected till now, we have around 25 species we have identified. And here we have made the species composition during the all particularly which are the method best for the collection, everything we have made here. Sweetnet is the best one, and particularly in different crops also we have made barnyard millet, which species is the dominant, and particularly in the brown top millet, foxtail millet, like that, which different species they are offering. And one thing I would like to mention here, why these different species they are offering on particularly on different millets. Particularly major one is the whole, because in the case of take it as a Kodo millet, Atirgona simplex only it will come, because whole leaves and also hardiness of the leaf is used to be there. That's why mandibles, particularly larval taxonomy, when you will do that, mandibles are totally different from the other species of mandibles. That's why that particular species is offering on particular crop here. And this is the same thing, species in particular little millet and other. Overall, how many species we have collected during this year. And this is the identification characters we have made, particularly identification made on the male gentilial characters, particularly hypophysial prominence. That is the hypophysial prominence below you are seeing, that is particularly used for the movement of this trifoliate process. During the mating period, they normally shoot flies, they will show the gentilial character part to the female, they will attract the females. Here these are the interfrontalia characters and particularly trifoliate process. Based on this we can identify not only that one, hypophysial prominence in different species we can make it out. And one very, very important, interesting thing, particularly in M.L. Srivastava, he published the paper in 1985. Particularly this 8 new species he made. But in that, one collection particularly made by Shafi in 1926, particularly he collection made and preserved in NPC, National Pusa Collection. I have observed the same specimen. It is the same specimen after 96 years we have got this specimen. Here particularly I would like to thank Gauri Shankar Giri. He sent a specimen to me, and this is identified. I have 2 specimens of Atirgona testasi. And another very, very important like that we have collection, this one Atirgona bengalensis and Atirgona faruqui also. After 112 years and 118 years we have got. Why I am telling, because when I went to Pusa collection, there are collection was damaged, particularly gentilial characters, they were damaged. Because this one can be used as a chin types in future also. And the other very, very interesting thing, one Juneja, he sent shoot fly adults for the identification, particularly from Jamnagar area. And he sent the first parcel in during the July, and afterwards I identified only one male I have got. And immediately I called him and told, no, it is something different. You sent me more specimens or a desert plant. He sent, and we have got around 9 male specimens. Among that we have found to be it is a new species. Particularly, why I am telling it is very close with the Atirgona theta. Particularly, it is available in particularly Philippines and Australia, and very nearer. I have put the photographs here. You can see. And this one I would like to name. Particularly in Jamnagar area, we have got more specimens. This is the Atirgona jamnagarensis. I would like to name it. And this is some of the publications I have made in particularly zoological records, and also we have made expertise. That's why identification services also we have done. and particularly we are working on also other aspects, agromyzids and caliporids, dipterans, and poster presentations also made in Animal Taxonomy Summit at the Geological Survey of India. And these are some of the publications due to the International Year of Millets. We have made some publications in Kannada language, and also some books, international conference also made, and award also got in that presentation. Some of the Kannada is this one. And overall, we have made all the publications, research, books, papers, all chapters also we have made. And overall, this year we would like to have more experiments. Earlier we have more than 70. This year more than 75 experiments we would like to conduct next year. This is the plan. And thank you very much.
Dr. Gange, thank you for the colorful presentation. And your this presentation involved less on experiments and more on taxonomy aspects also. But experiments, I think, other than screening and other things, I feel that you should have more of management of insect pests in different small millets. And management aspects, you have got only 2 experiments listed there in the technical program also. I think you can go for more of management of insect and other things, formulate more experiments on these things other than the routine evaluation. And it's a very, I appreciate your efforts in taxonomy of this shoot fly species and things. It's really good and it's wonderful. But what we need here is that more of evaluation aspects as well as the management of insect pests. And I have got 1 or 2 other observations that whatever you have shown in the insect pest, different dead hearts, those things like that. So in finger millets, temporal is important. In all other small millet crops, other 6 crops, shoot fly is this one major pest. But I see that the damage of the shoot fly is not more than 29% or so, whatever you have shown in different maximum. I think brown top millet it was more, and proso millet also it was more. But in another crops it was almost manageable. That is one thing. And second thing is that you have got now. The same question I was asking again and again. Have you got all the resistant and susceptible checks for all the crops for different pests now? What about other crops? Shoot fly for other crops? I can see from my presentation that you are spraying a lot of germplasm reliance in Bangalore and around Bangalore center only, and other places also here and there, but yes, I see. So you take some, because this is the unexplored area. So we need to find more of susceptible resistant checks in these things, and finally you can make it final. So screen some more germplasm lines in all the millets year by year, make a plan like that, and you can assign to some of the hotspot stations also. That also you can do. I see that you are doing alone in Bangalore. So 1 or 2 entomologists and Barampur also you can do it. I think some other places also you can find out. And Rani Cheveri you are not evaluating now?
Almora we have given, but another Mashapur went for PhD.
But see the hilly regions, so there should be screening of insect pests for hilly regions, Almora or Rani Cheveri. So you see that either it is screened either at Almora or Rani Cheveri. Rani Cheveri, if it is the facilities, so they may do it. So we have earlier you have identified also that also you can make it. And so that's very important for hilly regions. Those things are northeast regions as well as these hilly regions. So evaluation of insect pests is very important, and you see that you get in for evaluation from Almora or Rani Cheveri. And you have so many these things, fish meal evaluation, shoot fly, this thing like that. What happens that the fish meal trap is good or what? What this will come?
Good, sir. For evaluation we used to do that one, but the collection only I have to. Collection only is attracting females. That's good for us actually. You can use it for the management of.
Okay, that's fine. Then I also appreciate your another experiment or your basic study, that the geographical distribution of species of shoot fly, that is different 25 species you identified all over. This is a good study, and this one thing. So overall the progress is very good, and I again express my view that I suggest that you take as huge germplasm lands are there in Bangalore itself. They have got germplasm, the bank is there, gene bank is there. So you take germplasm, more germplasm yearly by year, so it will be at least 3-4 years. For the last 3-4 years, 2-3 years, you are already screened many germplasm plants. I think more than 2,500 plants finger millet you have screened. Is it not known? Yeah, like that only in other crops also, not only finger millet, in other crops also is very important. Pests are there. So more of the shoot fly and other pests are more in other crops. On finger millet only stem coverage. So you concentrate on more, you take more germplasm to evaluate and identify the resistance sources so that the breeders can use it. So for further comments, I will pass on to our coach.
Thank you, sir. Ganegar, nice presentation. One thing is, as our chairman pointed out, so you have very less trials and management. Why?
Normally we used to get that, but I have one treatment and one spraying.
But you are saying that the fish meal trap is working well. So why don't you use it for management? You can formulate one management trial by using this fish meal traps with different doses.
Yes.
And apart from that, you can compare with other traps.
Definitely, sir. I will do it.
You can formulate one management trial with this trapping system. Okay. So another thing, you have identified the number of species of shoot fly, but you are identifying yourself, or you are taking the help from others?
Myself, I am identifying.
So you are specialized in shoot fly.
Yes, sir.
So you are a taxonomist for shoot fly.
Yes, sir.
Huh? So will you identify for others also?
Yes, sir. I am doing, and also we are receiving some of the particularly response from other centers also. Like that only Jamnagar last year we met in this hall. That time I told him to send some response. He sent, particularly luckily we have got news.
Okay. Okay. So you have to take care of the basic work for the resistance aspect also.
Yes, sir, definitely. That one I have told, sir. Last we are doing biochemical analysis and all. Maybe next year we will present the biochemical analysis of the millet and compound.
Okay. Okay, and thank you. With all these comments, now I request comments from other delegates.
Dr. Ganigar, it's not a comment, actually just a suggestion or observation. Already the chairman has touched upon the screening of germplasm and identification of resistant and susceptible checks. Okay, so I do understand that apart from you, there are only 2 entomologists, so we can't find fault with the data which has been collected by other than entomologists. Okay, but in your tables, what I see is the resistance and susceptible check, especially in case of Rosso millet or ground top millet, or even I think in case of little millet, the so-called the entry which has been designated as a resistant check has more incidence than the susceptible check. So in the table it should not come actually, because it was really difficult for me to put into the VIC tables. Somehow they did not observe it much, but in many other cases the resistant check had more incidence than the susceptible check. Okay, so please see that the people who are reporting the data are properly trained. So you may call them for a small training also and how to take the observation, because in the tables, because it is going to be a permanent record. Okay, so it should not happen actually, because the susceptible check in many of the cases had less incidence than the resistant check. Okay, so please see that in the next year onwards. Thank you.
I wanted to touch the same point in another way. So actually sir also told you don't have any resistant, susceptible, defined checks. The first job should be that only now. So you define for each of the crop what is the resistant and what is the susceptible, what is the level. That is one part. Second is, do we have the protocol how to score the shoot fly traits?
Traits or
Traits. What traits you are not just okay. Data, for example, data is there. Okay, or, because these are all tillering crops. How you are accounting the tillering? At what stage it should be? Any set guidelines are there?
yeah,
For you?
yeah, particularly 21 and 28 days we are taking, sir, particularly. But whatever you have told, we are considering all. we can also bifurcate whatever you are told. Maybe main tillers and
something you see, we have to define that.
Yeah.
What we have observed at IMR is the lines which are found to be bit susceptible, they are resistant at their tillering, and vice versa observations were there. So which were good at tillering, they were less susceptible at this, and susceptible they were resistant at that. It's like that it is there. So which one how you will account both? So that aspect, anyway, if you want, you can discuss with IMR, Dr. Padmaja, who are also working on entomology. I told you that first is you define for each of the crop what is resistant and what is susceptible and what is the level. That is one. And second is look into these protocols, correctly defined for this. Third one is you are telling about this biochemical. Have those lines been evaluated for 2-3 seasons, validated, or just made 1 year and then you are going there, categorizing them as resistant, susceptible, you are going?
No, particularly only 1 year, sir. But now
don't do that. Just take 3 years minimum data you should be have for any one line. Such lines only you take for your any bubble analysis. Otherwise it will be waste.
Okay.
Okay, another one is, see, now you said, for example, in Codominant you have some simplex, some
yes,
so that has mandibles, very strong mandibles. So if then it leads to that each resistance breeding should be separate with separate traits for each of these crops.
Separate traits, okay, but different species they are attacking in one crop. We can't quantify each species because maybe 1% or 2%.
And finally, what is the implication for a breeder? What you say, these are the traits you go for breeding in this crop. Such traits also required for a breeder. Yes, species, yeah. For example, Kodo, that's what I took an example of Kodo, because Kodo you said it is the predominant.
Yeah.
So for breeder Kodo, you have to define these are the traits for resistance breeding. Otherwise, your all efforts go in vain. No implication for the breeding.
Dr. Ganiga, just a continuation of that. Will it be possible to define the breeding strategy depending upon the species which is predominant in a different small millets? That is what to say. The further extension of the whatever he has asked. So in case of Kodo millet, you told the simplex, it has a stronger mandibles. So will it really identify any trait which can lead to resistance? Means depending upon the species, can we devise some breeding strategy? That's what.
No, sir.
It's just exploratory level,
but we can work on that, sir. No. But the different species we can't make out.
We have to understand both host and the insect for resistance breeding. So what are the traits that actually against the insect and what is the traits which has to overcome these plant traits? Both if you understand, then we can have a strategy to breed it. So that has to come from entomology.
Yeah. But we have to go depth.
What I'm telling is not necessarily only identifying the species, you go into this aspect also. Yeah. So advise the breeders that you take these traits for this crop for resistance breeding.
One curiosity I have made, particularly whole length, breadth we have made particularly. Because in Barnard millet, the whole used to be there like a sorghum. But in that falcata species used to come. We can breed for the whole maybe shorter.
Yeah.
But in particularly in Kodo millet, whorl is very, very small used to be there. But the hardy the species used to come. But such things we have to go depth, sir. Right?
You have to go depth for resistance breeding, otherwise...
we have to quantify thickness, leaf of the thickness.
Exactly. Sorghum, what is being done, you just observe, discuss with Padmaja and group. They can also advise you how they are doing. Okay? Thank you.
Any other questions? Dr. Ganike, what Dr. Matsudan and they were telling that they have got standard operating procedures, is it not? They are made for entomology also, is it not? For all other pests. And different crops are there, and for every different crops there is a different methods of screening. Other things are also there, as it came from the discussion. So for little millet also, even till last moment also shoot fly is going to affect. You know the dead darts are there in little millet and posto millet also, and Kodo millet also to some extent, and round top also it is there. And for different pests, different crops, different procedures, minor changes will be there. You see that again revisit that standard operating procedure, whatever has been done. you people have done for all the crops, isn't it? Sorghum and all the crops. So those things visit once again and then make suitable changes as per the discussion with this and things like that. And overall, before that, I want the co-chair to tell anything about overall the presentation. So all the three speakers has presented very nicely. My request is they have to concentrate on basic research also apart from the applied research. And yesterday our DDG also pointed out that many are working on applied aspect but not on basic research. So that's why I request all the entomologists apart from applied aspect, and we have to go for basic research so that the basis for residence of particular line will be perfectly, we can give it to the breeders so that they can breed the lines for residence. So apart from this, I request the entomologists to formulate novel technologies for management of the different insect pests, particularly shoot fly and stem borer. So we are going for insecticide evaluation and also the bioagents evaluation. Apart from that, you can concentrate on novel strategies like RNA technology, like that. So you can think of some of the novel strategies for managing the insect pests. So very nice presentation. I am happy to be part of this technical session. I thank all the organizers for giving me this opportunity. Thank you, sir. Thank you, Coach. And my final comments are there. Very good presentation, sorghum and Stanley. You have presented the evaluation and all the other parts of mostly kharif sorghum and rabi sorghum. And see that for kharif sorghum as well as sweet sorghum also you have some management aspects and those experiments should be there. That is missing in sorghum. Otherwise, sorghum exhaustive study is there, and most of these things are there. And small millets we have discussed a lot. I think in pearl millet, I see that I don't know, we have not been present or something. You may present better so that we will understand. Dr. Sheikhout sir. So there is some scope for improvement of this program and what I see from your presentation. So if you are doing it already, it's okay. Otherwise, also you can note down and the experience of sorghum and small millets, and you can add it, and more of management to those aspects other than survey, you can add it and do experiments. So overall, all the nice presentation and very good progress, and thank you all.
Very good morning, friends. Now we have completed the entomology presentation. It is time to honor the chair and co-chair. Now I request Dr. R. Madhusudan sir, project coordinator of sorghum and small millet, come on the dais to honor the chair and co-chair.
Sir, please closer. Please, sir, closer. Please, go. See. Sir, one group photo, sir. What that one? Slide. విత్తనాలు నేను వైడే పెడతా. ఓకే సార్.
For tea now. Go quickly. Already we are late. Yeah, we'll go quickly for tea and come back for the next session. Next session is on outreach activities, steel production, IPR, and ICR Egress and partnership trial. It will start soon, so you just break for tea, for quick tea, and come back.
Dr. Stanley announced within 10 minutes or 15 minutes they have to come back. You announce 10 minutes break or 15 minutes break like that.
So it is 11 o'clock now. We will be starting by 11:15 sharply. After tea, we will be starting the session by 11:15 shortly.
रुमाल गिरा ఇది అటాచ్ మోడ్ రాలేదు టచ్ చేస్తే ఏది వైట్ బ్యాలెన్స్ జరుగుతుంది మళ్ళీ కనకలేదు ప్లస్ ఇంకోటి ఐఎస్ అవన్నీ సరిపోతుంది ఉందిలే అది ఉందిలే అది వదిలే కెలివిన్ వదిలేసి ఓకే కదా ఓకే ఈ బ్యాటరీ కెమెరా బ్యాటరీ 14% ఉంది. నేను తీస్తే లైవ్లో వస్తుంది కాబట్టి వాళ్ళు ఏ క్వశ్చన్ అడుగుతున్నారో తెలుస్తుంది.
రికార్డ్ చేస్తాం మొత్తమా?
రికార్డింగ్ సిటీగా అవుతాం
వచ్చింది తీసుకున్నాను స్టార్టింగ్ అదే తీసుకున్నాను.
ఎంతమంది వచ్చారు?
ఇలా పిచ్చిలు మారుస్తారు వాళ్ళు ఏదో ముక్కు అవి తీసుకున్నారు.
అవి నిన్నే తీసేసిన
తీసుకున్నా బిల్డింగ్ తీయాలంటే మాకు తీయించుకోవాలి.
ఏ బిల్డింగ్
ఆడికి పోయింది నేను రెస్ట్ వేసుకుంటున్నాను. మాకు బిల్డింగ్
టీ కాఫీ డిస్ప్లే మూసి ఏంటి నా అలాగే
మేడం మేడం లైవ్
Is there
बात किया था पैसा नहीं मिल रहा है ज़्यादा प्रॉब्लम नहीं देखी सरगम में ज़्यादा प्रॉब्लम है क्योंकि क्या అని మంచి పంపించినట్టే ఎందుకు ఆగిపోయింది సార్ ఆయన ముందరే ఆయన మరీ ఆగిద్దాం టుడే ఇంత పెద్ద మీటింగ్ పెట్టేది Excuse me, boss. बैंक ट्रांसफर करते हैं
We are about to begin the session on outreach activities, seed production, IPR and ICR Reconcile partnership trials. All are requested to be seated inside the auditorium.
అది ఏం చేయాలి తొట్ట పిండి నా ఇష్టం నాకు ఇష్టం వచ్చినట్టు పెడతా ఇది పెట్టుకోసారి మళ్ళీ పెట్టుకుని కావాలి ఇప్పుడు స్ట్రైట్ ఉంటా ఉంటుంది, ఆటోమేటిక్ స్ట్రైట్గా ఉంటుంది. దాన్ని చూసి కాదు, దీన్ని ఈడ చూసే పెట్టాలి. దాన్ని చూసి పెడితే అట్ట అవి నీకు తెలిసేదట
కందరే నాకు
కనప
కనస్తాను నాకు
కనొస్తుందా?
చేసిన మళ్ళీ వైట్ ఉంటుంది అవుతాను.
ఏం వేసినావు? బ్యానర్ పెడదాం.
The front chair. Whenever we are taking videos, it looks like it is vacant. Please come and occupy the front chair. A kind request to all the delegates to come and fill all the white covered front chairs. I would like to see all the white covered chairs to be filled with the delegates. So everything is videographed and photographed. So it looks like very much vacant. Kindly help us by coming to the front chair. Who are coming new, come and occupy the front chairs only. Welcome back to all the participants and delegates and dignitaries. We are going to start the next session on outreach activities, seed production, IPR and ICRISAT partnership trials. The chairman of this session is Dr. Sanjay Kumar, Director, Indian Institute of Seed Sciences, MAU, and the co-chair is Dr. T. Lakshmi, Head of the Department of Agriculture Extension, SVAG, Tirupati. I request Dr. T. Lakshmi, Head Agriculture Extension, SVAG Tirupati, to come on to the dais. I request Dr. Manoj Kumar, who is going to talk on FLDs in pearl millet, to come to the dais. I also request Dr. R.R. Chapke, who is the Principal Scientist in ICR IIMR, to come on to the dais, who is going to talk on FLDs in sorghum. FLDs in small millets will be presented by Dr. T.S. Sukanya. Please, madam, come on to the dais. Seed production in sorghum and small millets, Dr. T. Sugana may also come on to the dais. Seed production in pearl millet will be presented by Dr. Vikas Kandelwal. Please come on to the dais. ICR ICRISAT collaboration will be presented by Dr. Ephraim. I call him to honor us to come on to the dais. And IPR management and royalty distribution will be presented by myself. We have seven presenters on this session, and the chairman will be joining us shortly. So I will ask the co-chair to start the further proceedings. Dr. T. Lakshmi, madam, please.
Good morning to everybody. In the meanwhile, while the chairman comes, we will start the first presentation from Manoj Kumar.
Respected Chairman, Professor Sanjay Singh ji, Madam, Co-Chair, fellow delegate, scientists, I am presenting the progress report of frontline demonstration of year 2023 and 24. Next, please. Yeah, under the Pearl Millet, the National Food Security Mission program was completed in 2024 to identify and popularize the high-yielding Pearl Millet hybrids having better adaptation and to demonstrate the improved production technologies. Next, please. Next. Yes, these are some important technologies that were demonstrated during the 2023 in Kharif and summer, and these are improved versus farmer practices, full POP, biofortified hybrid, and some improved hybrid. Next. During this year, total allocation was 1,000 hectare, and out of this we conducted FLD in 666.8 hectare, and out of this 601.8 hectare during Kharif and 65 hectare during summer program. As per the ministry guidelines, we have to provide the FLDs with biofortified hybrids, and we tried, and 88% total locations was under biofortified program with the hybrid HSB 299, HSB RHB 233, 234, and AHB 1269. And these are the 586.8 hectare. If we go for the zonal classification, in zone A1 is the drier part of the country. We conducted FLD in 360 hectare area. Out of this, biofortified was 290. And zone A, the middle part of the country, 156.8 hectare was total FLD allocation, and out of this 100% under biofortified program. In zone B, out of 150, 140 was under biofortified, and in summer all FLDs were under biofortified. Next, please. If you go for the particular center-wise allocations, SKRU Bikaner, our ECRIP center, and they conducted frontline demonstration in 50 hectare area. The yield increase was 44.5 our control, and this was higher our state average of Rajasthan. Next, please. The Kajri KVK, ICR Kajri KVK Jodhpur also located frontline demonstration program in 30 hectare, and the yield was under demonstration plot is 1226 kg per hectare, which was 22.1% higher over the control, and the hybrid was used as HSP 299, which is biofortified hybrid. Next, please. The KVK Chankoti under SKRL Bikaner Center, they conducted frontline demonstration in 50 hectare area, and the yield increase was 19.8 hectare with the same hybrid, which was significantly higher over the state average of Rajasthan, that is 103 kg per hectare. Next, please. The KVK Plodi Agriculture University Jodhpur is the western part of the Rajasthan, which is the main area of the Pearl Millet, and they conducted frontline demonstration with HSP 299, which is 23.6% higher our control. Next, please. KVK Gudda Malani Badmer. This is the also main center and the highest area of this district. Badmer district, madam, has the highest area in the country of the Pearl Millet, and they conducted FLD in 80 hectare area during Kharif 2023, and the HSB is 299 biofortified hybrid were used in the program, and the yield increase was 45.8%. Because the farmer in the area, they are not using hybrid, they are using their own seeds. So that's why this increase was the 45.8%. Next, please. KVK Athiasan, this is Nagaur area of the Rajasthan, and they conducted frontline demonstration on improved practices versus farmer practices with the use of hybrid GHP 905, and the increase was to 1.6%, which is significantly higher over the state average, which was 2012 kg per hectare. This is the photograph of the frontline demonstrations and the field photograph during the field day. Next, please. In the Jalore area, there was no rain for more than a month, so that's why the whole program were failed in 50 hectare area. Even the sowing was done, but after the sowing there was the long dry spells, that's why all FLD were failed. Next, please. In the KVK Pokhara, that is Jaisalmer area of the Rajasthan, they conducted frontline demonstration in 50 hectare area with the use of HSB 299, and the increase was 28.3% of the control plot, which was yield is 1264 kg per hectare in the demonstration plot. Next, please. This KVK, Jaisalmer is another KVK, which is Jaisalmer, the large district. They have 2 KVK. Another KVK also in 20 hectare area, they conducted frontline demonstration with the use of this improved biofortified hybrid SSP 299. The increase was 27.7% over the control. Next, please. Rari Durgapura, Jaipur, under the Sri Kananandar Agriculture University, Jobner, and they conducted frontline demonstration with the improved biofortified hybrids, that is 233, 234 and SSP 299. The increase was 24.7%, which was significantly higher our state average of the Rajasthan, or as well as control. And the demonstration plot is was 2757 kg per hectare. Next, please. The Chaudhary Charan Singh Haryana Agriculture University, SAR, they conducted frontline demonstration on the this aspect of farmer practice, the use of private hybrid, suboptimal use of N, and negligible use of P and zinc sulfate. Our the improved practices with use of improved hybrid 299 and other recommended practices with use of atrazine and one hand weeding. The increase was 16.2% because the Haryana farmers are already using the private hybrids. The increase was slightly low. The increase which was significantly higher our state average. Next, please. The Punjab Agriculture University, Ludhiana, our Agri Center conducted frontline demonstration in 20 hectare areas with the use of this improved biofortified hybrid SSP 299. The increase was 12.8%. Next, please. Jamnagar, Junagadh Agriculture University, Gujarat, they also conducted frontline demonstration during Kharif and summer both. During Kharif seasons, the increase was 10.4%, and which was significantly higher over state average as well as control. These are the some photographs under the field conditions at Jamnagar Center. Next, please. In summer 2023, the yield increase was 6.7%, and the improved hybrid GHP 1129 was used. In 20 hectare area, the demonstration yield was 3959 kg per hectare, and this is the crop situation during crop season and frontline and visit of the scientists in the field. Next, please. In Gwalior, Rajmata Vijayaraja Scindia Agriculture University, Gwalior has also conducted frontline demonstration. Gwalior is our agri center and conducted frontline demonstration in 20 hectare area. The increase was 27.7% over the state average. And the hybrid use is SSP 299. Next, please. The Dhule sector, Maharashtra, is also conducted frontline demonstrations with the use of test hybrid Adi Shakti and full package of practices, and the increase was 14%, which was significantly higher over state average of Maharashtra as well as the control. Next, please. The Vijaypur Karnataka Center, RARs Vijaypur, also conducted frontline demonstrations with the use of VPMS 9 and VPMS 14 variety, and the increase was 13.7%, which is significantly higher over state average of the Karnataka. Next, please. Vijayanagaram Center, Angaru, also conducted frontline demonstration during Kharif 2023, and this Vijayanagaram Center, they used the hybrid was ABB 04, and the increase was 28.1%, which was significantly higher over the state average of this Andhra Pradesh, which was 2273 kg per hectare. Next, please. During the summer, they also conducted frontline demonstration in the 25 hectare area, and the increase was 23.6%. Next, please. The Aurangabad Center also conducted frontline demonstration program with the use of hybrid, biofortified hybrid AHP 1200, and the increase was 24.4%, which is significantly higher of state average of Maharashtra as well as control. Next, please. The Coimbatore, Tamil Nadu, TNAU Coimbatore also conducted frontline demonstrations with the use of this ASP 1200, and the increase was 82.8%, was significantly higher of state average of this TNAU Tamil Nadu, and the demonstration yield was 3156 kg per hectare. Next, please. Anantapuram Center, Sangaru, also conducted frontline demonstration in 20 hectare area, and the variety was used by ABV 04. The increase was 18.5%, which was low than the state average of Andhra. Next, Peramallapulli, Andhra Pradesh, they also conducted frontline demonstration during summer 2023, and the increase was 10.1%, which was significantly higher over control, not over the state. and the demonstration was 1953 kg per hectare. This is the overall about 23-24, and this is the proposal of frontline demonstration of 24-25. In the next year, we have planned demonstration of the Jaipur centers for the 50 hectare, Bikaner center for the 100 hectare, Jamnagar 30 hectare during Kharif, 20 hectare during summer, 50 hectare, Hisar से चौधरी चरण सिंह हरियाणा एग्रीकल्चर यूनिवर्सिटी 20 हेक्टेयर, IRI KVK गुड़गांव 20 हेक्टेयर, ग्वालियर 20 हेक्टेयर, औरंगाबाद 40 हेक्टेयर, कोयम्बटूर 20, विजयपुर 20 हेक्टेयर, धुले 20 हेक्टेयर, अनंतपुरम 20 हेक्टेयर, ICR KVK काजरी 20 हेक्टेयर.
Why in Coimbatore and all it is very high? What are the factors?
Yes. So some of the centers, like some Angarud centers, they are less than the state average because their seed, the yield, which is only the seed production program was there. Farmers are not using for the grain purpose mainly. So that's why this is low. And in some other centers like Coimbatore, the farmers are presently using their own seeds. So that's why by the use of the hybrid, the increase was more.
Why in Perumalpalli it is decrease in yield?
And over the state level,
yes,
they are also using the farmer are using F2 or own hybrid, own seeds. That's why.
Okay. Can you list out which are the promising varieties?
For Perumalpalli, that's the ABV04. They are using both at Perumalpalli, Anantapuram, and this another one center. This is Vijayanagaram. They all are using ABV04 because as per ministry guidelines, you have to use the hybrid or the variety less than 10 years of the release. Don't use more than 10 years.
Now I request the delegates for the discussion.
24-25 program. Both so the 24-25 technical program slide.
Yes. Next.
Manoj, here in Jamnagar, actually the allotment is a higher number because due to higher number in 23-24 because of the international area of millet. You know, the Gujarat have a highest area in the summer as compared to the Kharif. So you reduce the area in the Kharif and 10 hectare increase in the summer.
Okay.
Second. Okay. Last year you released when amount?
On 19th.
19th
March.
19th March, and we have received on 25th from our university.
Yes.
How it is possible to conduct the FLD?
Sir, the budget will be released by the ministry, and the ministry released on 18th, and we on the next day we sent it to approval from the project coordinator, director IMMR. After the approval from the director IMR, we released to the different centers.
This is actually
that's why due to delay from ministry only.
This is actually some little type answer. I am
no, I have the papers of the allotment and the budget release also.
Dr. Manoj,
yes,
I was thinking also to ask this.
Yes.
I received many telephones from Rajasthan region that they are not getting money in due time. But if such thing is happening, how you will be able to conduct? You should contact us, or we should pursue the matter so that in time getting a fund is very important, you know. So nobody is telling to us. So that means you are admitting the fault. Rather than we may not conduct this trial. If actually the people will not be getting in due time, how you will be able to conduct the trial? So this telling that ministry has released this time is not the answer. You have to pursue with us. Nobody from your side has told me. I received many calls from the executing side. This is not true. You have to be in touch with us.
Sir, even Tara ma'am written 2-3 letters, sir, to the ministry that you release.
Why you are bypassing us to council? We should pursue there. We are sitting.
Okay, sir. Next time we will do.
Should not do like this. Okay.
It's you said the demonstration FLD is your FLD value is less than the state averages, correct? The reason you said is already farmers are cultivating the varieties. Yes, correct. Now, if that is the case, then what we are demonstrating is actually inferior to the farmers cultivating varieties. No, sir. Nowhere that situation, sir. That was less than the state average, not from the control. Less than the state average. Correct. Less than the state averages means the farmers are already cultivating better varieties. Is it correct or what? No, sir. Then I am. Can you try so? Please, one slide is showing. Next, or next, please. Next, next, please. Or next, और चलिए और चलिए और चलिए yes. Yes, this is the case. Demonstration is 1200 is there. State average is 2252 is yes. And demonstration yield is 1200 and control is 1013. You don't compare with control because they have a state average. Then a state average is 2252 means what actually? It indicates that farmers are already cultivating better varieties compared to your variety. So that can go as a variety. Sir, in Andhra Pradesh, most of the areas under seed production program. So average was written from that. That's why this is 2252.
There's no.
Sir, please guide.
If that is seed production, then
Dr. Manoj, in your presentation, you have to include the PC ratio also.
Okay, sir. Secondly, we will write to centers to provide the detail of the BC ratio and net return cost benefit ratio.
Secondly, the demonstration showed extremely high, should not be included in your report.
But sir,
means either they have shown their poor quality grain or they have not conducted the FLD seriously.
But sir, these data are provided by the center. We are presenting that.
No, at your level, you should not.
Okay.
Because it showed the millet percentage of this your FLD. Or as far as the conduction of the FLD, either the in charges have sent the sheet for this season FLD, or if you are showing this program at this time, then how it is possible to conduct?
Sir, it has already circulated. It is already circulated.
Means it is only
for the information, no?
Yes, information center already circulated.
Because in general, this group meet should be.
No, sir. Implementation has already been done.
Okay, thank you.
Good morning. Myself Dr. S.K. Jain from Durgapura Center. Madam, we received the grant last year in March 27th. And after that, it is not possible to use the grant. And in April, and continuously sending the mail to PC unit, but we not receive the response. And grant is not revalidated till date. So we are facing the problem for the conducting the effort.
Sir, we have already sent your email for the approval to the director. And after the approval from the director, it will be circulated to you.
But sir, in Millets, we purchasing the seed from the state seed corporation and other units, so we are facing the problem for paying to agencies.
Dear participants, we have our Director, Indian Institute of Seed Science, Dr. Sanjay Kumar with us, who is chairing this session. We welcome you, sir, to chair this session. The first presentation is going on, sir. FLD on Pearl Millet.
डॉक्टर मनोज, जैसा कि डॉक्टर जैन ने बताया कि सभी के यहाँ आके आपने मार्च के लास्ट में इवन तो आफ्टर 20th ऑफ मार्च आपने पैसा सबको रिलीज किया, वो खर्चा हो नहीं पाया, तो उसको रिवैलिडेट करें अगले सीजन के लिए, क्योंकि आपका जो एफएलडी का जो पैसा आ रहा है वो हरदम लेट आ रहा है और इन केस मंथ ऑफ मार्च में आ रहा है, तो जिसका प्रॉपर यूटिलाइजेशन हो ही नहीं पा रहा, तो जो एफएलडी लग रहे हैं उनका पेमेंट भी नहीं हो पा रहा है, नया आप पूरा इनपुट दे पा रहे हैं, तो इसको ऐसा कीजिएगा जो अप्रैल आता है अप्रैल ऑनवर्ड्स उसको रिवैलिडेट करके अगले साल के लिए, ताकि वो एफएलडी का पैसा यूटिलाइज हो जाए और आपका जो नया पैसा आएगा वो नेक्स्ट ईयर में यूज हो जाएगा.
Okay, sir. Yes, sir. One center, Jamnagar, they requested, and Director IMR already approved, and we have already circulated to Jamnagar center the revalidation. And other centers, they may send a mail to us, and we will get approval from the Director IMR.
Just a suggestion. Can we divert or increase some FLD for summer segment? Because summer area is coming up largely in different states. And in that proportion, I'm not seeing FLDs in different states.
Which state you require, sir?
In Maharashtra particularly.
But they are not demanding Maharashtra state or Dhule center or Aurangabad center.
I'm from private sector. I'm just giving you the input. Summer sex area is increasing.
Okay.
So you can demonstrate our good varieties in summer segment if possible.
Okay, sir. We will ask from our Dhule and Aurangabad center. If they are interested, we will provide.
Okay.
Okay, sir.
Sir, I want to know about the average yield of ABV04. What is the average yield?
ABV04. ABV04 average yield is 13 to 14 quintal. Yes, biofortified hybrid, so yield.
That's why I'm asking.
Yield is low due to biofortified. Yield is low.
Then it cannot be compared with the state average or the high yield.
Yes, sir.
So that may be.
Yes, sir.
Okay, thank you, Manoj.
Thank you very much.
Now I will call Chapki.
Respected Chairman, Co-Chairperson, and respected ADG Sir, PC, XPC, Small Millet, and my dear colleague. I am going to make a presentation on progress made under frontline demonstration on sorghum. So this program is sponsored by Department of Agriculture and Farmers Welfare from Ministry of Agriculture, Government of India. And we are getting 6,000 per hectare
fund to conduct this FLD program, and this is the pattern of the funding structure. You can see that this for key input we have got 5,100 rupees. Then other extension program like field day, farmer day, 250 rupees per hectare. And then some display material 250 rupees, and some visits, but excluding the TAD there, so that is there. So likewise there is a 6,000 rupees per hectare budget we are getting. Next one. So what we are trying to address from this FLD is that we are trying to solve some address some issue of biotic stress from this Kharif, especially we are trying to put some shoot fly resistance or some grain mold resistant variety or cultivars in the field. And in case of this climate adversity and risk also, because we are conducting this FLD throughout the year in 3 seasons, Kharif, Rabi and summer also. So during Kharif season, this crop is totally dependent on residual moisture. So moisture conservation technology is also very much important. So we are putting this moisture conservation technology into demonstration, and we are trying to put some short duration, medium duration, and which are suitable for this intercropping that cultivar we are putting. And some location specific problem also we are trying to address it because many people are having some question that in some area why there is more yield and in some area it is low yield, because everywhere that agroecology is not the same even soil type. So we are trying to put some soil type based cultivar in the field. And both this component we are trying to use that input use efficiency also by advising some soil test based fertilizer application, some how to maintain seed rate and time of sowing. Your time of sowing is very, very important in case of sorghum, because otherwise there will be a lot of shoot fly attack and crop will not get good. Then low productivity is a major problem in case of Rabi things. So we are putting high yielding varieties and improved cultivation practices also with crop management. And ultimately we are trying to address that consumer and market preferences, because ultimately we want good quality of grain and even grain color, and also equally important fodder quality is also very much important. Next one. So as I told you, we are conducting this FLD during 3 seasons. So I am starting with this Kharif sorghum season. Last year we have organized 209 FLDs with the help of 6 different centers. You can see that Akola Center we have conducted with this CSV 34 variety. So likewise I am going to explain you details one by one. Next one. And package of practice, these are the package of practices we have followed in the FLD program, FLD demonstration. I am not going to explain one by one. Go next. So I am coming to this FLD which was conducted by the Akola Center in Vidarbha region of Maharashtra, because it is very important area for this Kharif sorghum, but unfortunately that area has been going down due to several reasons. So there last year they have organized FLDs on CSV 34 variety, which is dual purpose variety, recently released in the 2017, and you can see their performance in terms of grain yield 44% higher than their farmers' existing practices, and which is resulted into 58% of net returns. Next one. In Madhya Pradesh Malwa region last year CSS 31 hybrid was demonstrated, and it has performed well with the tune of 57% of higher grain yield, and which is resulted into 90% of higher net return than the farmers' practice. Go ahead. In case of this, again in Marathwada region, where both the season sorghum is very much popular during Kharif as well as Rabi also. So we have demonstrated one hybrid CSH41 because hybrid has a first preference during this Kharif season, and one more state release variety, that is a Parvani Shakti, and both will perform better than the farmers practice to the tune of 68% of higher grain yield, and which is resulted into 95% of net returns. Go ahead, next one. In case of Andhra Pradesh, that Vijayanagaram area, with the help of the Vijayanagaram Center, we have demonstrated CSV 15 variety, which is dual purpose variety. It is equally good for the grain as well as fodder purpose, and it has performed very well with the tune of 27% of the higher grain yield, and which is resulted into 33% of net returns. Go next. In case of Gujarat, in Surat and surrounding area, they have demonstrated CHH41 national release hybrid and two state release varieties, that is GJ41 and GNJ1. And both were performed on an average at 23% higher grain yield, and which is resulted into 34% of net returns. Go next. In case of Rajasthan, Udaipur region, it is very important area because there is very low rainfall. So they have demonstrated CSH 30 last year, which is performed better in terms of grain yield, that is 69% higher than the farmers practice, and which is resulted into more than double it, 156% in terms of net returns. Go next. So when we see overall performance of all the centers, all the area, so we found that overall our demonstrated technology is performing to the tune of 47% of higher grain yield, and in case of store yield, that is 43% of more than the farmers practice. And next one, in terms of economics benefit, if you see, so all the demonstrated technology that is giving on an average 74,000 rupees per hectare net returns, which is 72% higher than the farmers practice. Go next. Now I am coming to the Rabi Sorghum FLD, which were conducted during last year with the help of the 7 centers, but last center is a summer sorghum center. So I am explaining one by one. Go next. These are the package of practices we have demonstrated along with the cultivars and other technology. And go next. Go next. And these FLDs were monitored by our monitoring team. And one more mechanism for this monitoring is that geotagging, because all the implementing center are this implementing center mainly agronomists are conducting this FLD, and they have their mechanism of monitoring of that by geotagging. Geotagging is very much compulsory, and this our scientist team of monitoring also this trial during the crop season. Go next. So as I told, you can see from this picture that not only we are putting high yielding cultivars in the field, but we as I told during Rabi sorghum, that water moisture conservation technology is very much important, because this crop is growing on the residual moisture of the monsoon. So we have to have some moisture conservation technology, that is that compartmental bund, formation of compartmental bund. We can see from this implement, farmers have to prepare that compartment bunding during the Kharif season, so that monsoon rain can be stored for this during that season, and that moisture can be utilized for the next crop. So by doing this moisture conservation technology along with the improved cultivars in this Rahuri area, that moisture conservation technology along with Phule Suchitra variety performed very well to the tune of 54% of higher grain yield compared to the farmers practice, and which is resulted into 77% of net returns. Next one. Yes, This is another in case of Marathwada region of Maharashtra. This is also a very good area for this Rabi sorghum is concerned. So they have demonstrated Phule Supermoti. This is a state release variety Phule, Parvani Shakti, Parvani Supermoti, and CSV 29R, which is a very proven variety which is performing all the area equally very promising performance it is giving. So overall average when we see, so we have got 57% higher grain yield than the farmers practice, and which is resulted into 72% of net returns than the farmers practice. Next one. Yes. Similarly, in case of the Solapur area, we have got a similar result. Go next. And in case of this Vidarbha region, this is the new area. First time we have introduced Rabi sorghum in that area, because it is traditionally a Kharif area, but people are taking up new this Rabi sorghum because of higher price. So we have conducted some demonstration with the state release, and we have got 39% of higher grain yield than the farmers practice, and which is resulted into 47% of net return. Go ahead. Next one. Similar in case of Karnataka, in Vijaypura area also, we have followed this moisture conservation technology and this CSV 29R variety, which is very promising. I have already told. Go next. This is the case of Dharwad area. Here also SPV 2217, that variety, state release variety, was performed very well to the tune of 14% of higher grain yield than and 21% of net returns than the farmers practice. Go next. Next. In case of this Telangana region, that Tandur area also, that Tandur zone now one that was performed very well in terms of yield and net returns also. Go next. When we when we see all the overall performance across the center, in case of Rabi FLD is concerned, so we have found that 34% of higher grain yield we have got than the farmers practice, and similar same in the case of store yield also. Go next. And which is resulted into 41% of higher net returns than the farmers practice when we see that economics. Go next. Then this is one more demonstration we have conducted in summer sorghum in Tankasi area, that Tamil Nadu state. So where we have mostly the Kharif cultivars are performing well. So CSV 39 and CSV 14 were demonstrated, and it was performed very well to the tune of 72% of higher grain yield, and it is resulted into good result. Go next. Yes, as per other extension program to make aware to the non-trial farmers, each center have performed 2-3 activity in every season. Go next. And it was also published in local newspaper also, that performance. Go next. And also we have provided some resource material, and also we have updated this package of practices, and yesterday it was published. So this is the plan for next year, that is 24-25. We have got already approval of 200 hectare FLD and of the 12 lakh rupees. So with this and detailed program have already been discussed in the technical session program, and it will be circulated to you all. Thank you very much.
So, thank you, Dr. Chapke. Just to one point, in most of the cases wherever you have demonstrated varietal technology, you have not retained the year of release. So that, in fact, I understand that it's less than 5 years, most of the variety, right? But my question is in fact related with this, because in the sorghum, this varietal replacement rate is very low. And that's so that the new variety is not coming in the seed chain. So if we see the data, it's around 24% is only of last 5-year release in the present seed system. And if we take the 10-year release variety, it comes around the 59% only. Though the other millet crops
bajra and this finger millet. That has a good variety replacement rate. But what is the reason why this sorghum new variety is not getting popular? Do we have, in fact, need more extension work for the new release variety, and what should be done more?
Actually, from a station point of view, what we observe, sir, in the field that nowadays farmers' preferences are changing. Earlier it was for hybrid also, but now they are changing to variety because of dual purpose this thing. They want some grain as well as good quality fodder. So in case of that new variety are performing better, but that seed industry is not coming forward to multiply that seed. So that is a little bit problem to promote that good varieties.
That's a different thing. The seed industry, in fact, in the sorghum, this private sector has more than 90%. No, sorghum is around 72%. Around 28-30% is the public sector.
Yes.
So 28-30% is in the public sector. So our data calculation is only on the basis of the whatever the indent we receive from the government side. So we are not competing with the private in calculation of this varietal replacement. But still it's very low. That's my point and my concern.
Now it is open for discussion.
Yes, sir.
Good morning all. I am Dr. Nisha Sapre from Indore Center. Sir, as per Chair asked about the changing in variety, so sir, in this year we have a new variety RVJ 2357. It is a dual purpose variety. So sir, we have distributed to at least 50 farmers of our FLD and about 200 farmers of different NGOs and other sections. So this is regarding the new varietal replacement. And sir, one complaint regarding the FLD. Sir, last year we didn't got any funds from FLD. Besides this, we did, sir, 50 FLDs. So many payments are pending still now. And again, this year we are again allotted 50 FLDs and we have already distributed our own seed because we have, but we also want hybrid seed from IIMR, but due to the scarcity of funds, they deny us to get the seeds. So, sir, this is a big problem for the funding, sir. So we are handicapped without the funds. We could not do very well without funds, sir.
Yes, it is very much clear. But just whatever, they also have some limitation in releasing funds. Whatever money they receive from government, certainly they distribute it to all of you. So they have some limitation. But other side, if your variety getting popular, that's also in the interest of your university or institute. So if institute or university is spending it in the money in the development of variety, it has no meaning until and unless it gets to the farmer. And for farmer, this demonstration is very important. So whatever, if you are spending some money from your own resources, I think it's not against the interest of your university, it's very much in the interest of university, because your variety is getting popular. Right? So you will get the more indent for your seed and everything. So ultimately, university will get more data.
Okay. Sir, I can understand, but our variety, and we are doing well for our variety popularity, and we are also distributing. But regarding the FLDs, we also need some facilities to give our farmers, like we have to visit there, we have to provide some other assets, so that
this point already taken. I think they have already noted down on the concerned PT and the director is here, so they have already taken care. Yeah, they will actually. Director Pradhan, so.
That same thing was raised here in case of corn millet also. That is a genuine concern. You have to take care of that. So my concern is that in case of these FLDs, good sorghum particularly yield advantage, at least 25% we are seeing here, average we can say. Thing is that concern is that area is declining, particularly Kharif sorghum, and target is rain-fed area, upland area like that. So here it is a correlation is different. How do you justify varietal replacement is different? But in case of the rain-fed upland type of ecology, is replaced by something else, not sorghum. Is continuously there is a decline. What is your response to that? What is your observation for that?
Sir, my observation is that, sir, when we go to the farmer, they are very much concerned about the profit. So they are getting, and during this Kharif season, they have a lot of options, whereas it is not case in the Rabi season. So in this, during this Kharif season, they are going for some other crop like soybean, cotton, where they are getting little bit more that benefit. So that is one of the reason. Another reason is that, sir, because this area has gone down like anything, and few farmers are growing sorghum, but they are in isolation. So there is heavy bird damage is there. Even most of the farmers, they are not able to harvest single grain from that. So that is also one more factor of discouraging this Kharif sorghum cultivation.
Myself, Dr. P.S. You have mentioned in some slides that the grain yield is increased 57%, but the net return 94% higher as compared to FLD and your farmers' practices. In some areas 69%, but net return 156% higher as compared to the farmers' practices. What is the reason? Because the yield increase, yield means your grain as well as the stover yield. That means how you can calculate that this much of net return is increased.
Yes.
The preference in case of palm millet, the preference towards the desi varieties, or we can say local variety is in marketing, or we can say price of the desi variety is much better than your hybrids ones. So what is the reason maybe, or how you can calculate the cost of?
Yeah. So it is not a case, sir, because everywhere farmers are not getting same price, na? Because there are different price for the in different regions, and they are not selling that their produce to the government agency. They are selling to the local trader. So they are getting very. There is a lot of variation in the price. So whatever price they are getting, that we are counting for this calculation. So it is not uniform, na? It is very region wise.
अच्छा, MSP सभी क्रॉप्स के लिए होती है. सेकेंड थिंग ये था कि वी आर
वो होती है सर, लेकिन कहाँ पे प्रोक्योरमेंट हो रहा है?
सेकेंड थिंग ये होता है कि जैसे यील्ड आपकी 57% बढ़ी, तो व्हाट आर द रीजन कि आपकी जो नेट रिटर्न है वो 94% बढ़ गया? वो क्या रीजन था? क्योंकि प्राइस आपकी ग्रेन की भी वही है, फोल्डर की भी वही है, देन हाउ पॉसिबल है?
नहीं, वो प्राइस तो चेंज हो रही है ना रीजन टू. महाराष्ट्र में कुछ और मिल रहा है, और आंध्र प्रदेश में कुछ और प्राइस मिल रहा है.
साहब, आप महाराष्ट्र की बात कर रहा हूँ मैं. महाराष्ट्र में 94% आपने नेट रिटर्न हायर बताया है, जबकि यील्ड आपकी 57% हायर है.
हाँ, तो Maharashtra is not same. There are 4 different regions, so there are different procurement at local level. एक विलेज में इतने पैसे में खरीद लिया तो दूसरे विलेज में जरूरी नहीं कि उतने पैसे में खरीदेगा. Whatever price is getting farmer, that we have calculated. So it is varying. There is lot of variation. There is no uniform price.
Anyway, so please check it. Whatever is point here is right. Maybe the cost of cultivation is more in the your other variety, and maybe I'm not sure about this, but there may be some reason. So
yes,
check it about.
There may be then that this much of difference is never comes under this calculation of the net return and BC ratio.
Any other questions? Okay, thank
Sorry,
you.
in case of Kharif hybrid FLD, I observed that in all the appendix you mentioned farmer practice means used private sector habits. I have seen that everywhere the yields are very low in case of farmers practice private sector habits. In everywhere. I think this is just my observation. And if sir mentioned that 90%, 70% something area is occupied by private habits. So just look into that.
Okay, thank you, Dr. Chowdhury.
Sir, Madam, good afternoon, sir. Good afternoon. One kind of submission that I'm taken from Tandok Center. One submission that regarding the sorghum FLDs, apart from varietal replacement and new varieties demonstrating technologies, there are good agronomic technology like moisture conservation, as you said, and there is a possibility for mechanized harvesting like it is going on in Maharashtra. You please try to see the possibilities at other states also for mechanized harvesting, especially for hybrids. And one more, sir, due to non-receipt of timely the budget allocation, as the madam said, in addition to that, we are concentrating on a varietal, new varietal demonstrating technologies only. We are confining because of this. We are not planning, able to plan the moisture conservation and other technologies because of this. And for our center, there are last 2022, 23 and 23, 24, we didn't receive any funds. Please to see the status and please, thank you very much.
Let me clear that in case of that mechanization, there is no provision in this for the mechanization. Okay, so that FLD will go to some CIE Bhopal like that. So whatever is concentrating here as per guideline, that is on production technology. Okay.
Here it is, I need to bring one point to all of you. As soon as the money comes from BFW, we release the fund to different centers for FLDs. The fund released from BFW itself is taking time. So whether even if you put pressure on us and we put pressure on us, unless and until they release the fund, nothing can be done. So the delay is mainly because of the delay in funds from BFW. So how much ever we discuss on that point, nothing can be done unless the release of funds from BFW is expedited. So please all of you note it, as soon as the funds are received at IIMR, all the funds are released to respective centers.
Shall we move on to the next presentation? Dr. P.S. Sukanya, Madam, restrict to 10 minutes.
Respected Chair, Co-Chair and delegates, now I am going to present the progress of frontline demonstration in small millets during 2023 and 24. So 14 centers involved in conduction of these frontline demonstrations. So out of 14, 3 centers are voluntary centers. Next. These are the locations of the centers involved in the implementation. We have conducted this frontline demonstration across the country where the major millet producing area is there. Next. So the frontline demonstration usually conduct with the objectives are to demonstrate the potential available in the recommended package. Not only the variety, we give importance for the agronomic management and also integrated crop management, and even the plant protection measures also we usually involve. Then to popularize usually 10 years below the notified improved variety, recently released notified and improved varieties are usually involved. Then the third objective is to bring synergy among planners, researchers and farmers. Usually here scientists, actually FLD provides direct linkage between farmers and scientists. So scientists are involved in execution, planning and even the monitoring. So that is why, and he will get the direct feedback from the farmers so that he can improvise the research accordingly. So these are the objectives we work with. So seeing is believing. So this is the best extension strategy to educate the farmer as well as training the extension functionaries. Next. So before going for frontline demonstration, we go for PRA technique, that is appraisal technique, to know the resource as well as requirements of the farmer to decide what best technology they have to address. So these are the constraints we could notice from different centers. So soil, so we work with diverse soil types and diverse climate, arid, semi-arid and even humid climate also we work with. Then farm mechanization technology. So we work, usually FLDs are worked in cluster approach. So we see the mechanization also we involved. So where FPOs and the cluster villages, so we employed that. Then the sowing of small millet, usually farmers they go for delayed sowing. That is why the productivity of these crops are much lesser than their potential capacity. Then the farmers, they usually grow these crops where no crop comes. So that is why the productivity of these particular crops are less. Then weed menace is a very big problem in small millets. So because farmers are not not adopting the line sowing, so this is also an important constraint. Then seed production, the lack of seed, the latest varieties at the farmers get. So these are the constraints, and also dominance of middlemen in tribal areas where the farmers they cannot sell their produce to the consumers. So these are the constraints we could see. Next. Previous slide. Previous. Can you please open PDF, madam? Okay. So these are the technologies demonstrated. So we worked on this concept. The first and foremost thing in FLD is introduction of recently released varieties. Then even the ministry also advocates to go for organic source of nutrients and organic source for managing the pest and disease. Then promotion of INM and application of micronutrients. These are essential because our soils are deficit in this most of the nutrients and timely sowing. These are the important cost and low cost input management factors, timely sowing, line sowing, and in finger millet transplanting. Transplanting it is actually a contingent measure to overcome the stress, and then weed management. So this also the thematic area we work with. Then need-based plant protection measures, and particularly we went for mechanical when the FLDs were FLDs were adopted in cluster approach. Then millet-based intercropping system, and some of the centers they facilitated the farmers group prevailing in the area by giving the processing equipment and also value addition marketing. So these were also addressed in our FLD program. Next. This is the package of practice we demonstrated. So right from sowing to plant protection. So and this particular table where the center and crop-wise breakup of area. So totally we demonstrate 300 hectares. So in 6 small millets covering 1,648 beneficiaries. Next. So these are the improved varieties, and most of the varieties respectively for important states where they have recently released, they are high yielding varieties and the drought tolerant, and also most of the varieties are tolerance for pest and disease. So those varieties only we have selected for demonstrating and frontline demonstrations. In Karnataka, Ravi, finger millet, foxtail, little, Kodo we demonstrated, and Uttarakhand, which is finger, Andhra Pradesh, where finger millet, foxtail and little. So Madhya Pradesh, in Dindori we demonstrated in little millet and Kodo. So in Tamil Nadu, almost all the crops were demonstrated involving the improved varieties along with the crop management factors. Then Maharashtra, finger millet, then Chhattisgarh, we demonstrated in finger millet, little as well as Kodo millet. So Chhattisgarh also in Gujarat, finger millet and little millet. So these were the crops selected for demonstration under these states. Next. So in among states we conducted 300 hectares of demonstration covering 1,648 farmers. So out of this total area, maximum area is being allotted to finger millet since it is a major area, followed by little millet and corner millet. Next. So in Karnataka, we demonstrated finger millet, Kodo, foxtail. 4 centers were involved: Bangalore, Hageri, Mandya and Hanmanmatti. So here the percent yield increase in case of finger millet, we could see a 16% yield enhancement in the demonstrated area compared to farmer check, where usually farmers they go for local varieties along with
management factors. Then next, Kodo millet, we could see 18% yield enhancement in the finger millet, in foxtail 28%. So this is the yield, percent yield increase over the check. So, and also accordingly the BC ratio, the net returns also considerably higher in demonstrated area. Next. So Uttarakhand, Almori and the Rani Chowri centers were involved here. They have demonstrated BL 376 and BL 352. There were very promising varieties with respect to yield as well as neck blast and also of short duration. So in case of barnyard millet, they have demonstrated PRG1 BL 207, which is found to be high yielding variety in barnyard millet also. These are the promising varieties, latestly released varieties. So here also we could see the enhancement towards yield is high, around 40 to 50% yield enhancement can be possible. Next. In Andhra Pradesh also they have demonstrated finger millet, little and foxtail millet. Here also there is a possibility of enhancing the yield to an extent of from 23 to 52% in small millets. Next. So in Dindori they have demonstrated the area in little millet and Kodo millet. Here also there is a possibility of more than 100% since the tribals are growing the local varieties which are very low yielder, and also the management factors, the poorly practiced. That is why we could see so much enhancement in the yield along with higher net returns. Next. Tamil Nadu, Atiyandal is a very peculiar state where we can see all the millets. That is why we demonstrated all the millets maybe in less area. So here also there is a possibility of enhancing yield to an extent to 30%. Next. So Maharashtra, Kolhapura, they have demonstrated, and finger millet, so involving Pule Nachni. So it is a very recently released variety having high yield. So it was demonstrated with the local variety. So here also there is a possibility of enhancing yield to an extent of 60% in case of finger millet. Next. So in Jagdalpur, they have demonstrated finger millet, little millet and Kodo millet. Next. In Ranchi also we demonstrated finger millet having the variety BBM10. So it's a high yielding variety. So compared with local check and farmers practice. So there is 38% yield enhancement can be possible by going for demonstration. Next. So Wagai also they have demonstrated CFME 2 years back. It is released biofortified varieties. So this they have demonstrated, and they could see the higher yield in case of demonstration area. Next. So with respect to results in finger millet, there is a possibility of yield enhancement to an extent of 46% based on the mean of yield obtained from different centers. And in case of foxtail millet also there is 29%, little lesser than the finger millet. So there is possible. Kodo millet also there is 57% yield enhancement can be possible by going for frontline demonstration. And in case of little millet also we can see a very high considerable percentage here. Then Atiyandal, so there is also a possibility, particularly in Proso millet, there is a possibility to an extent of 44%. Next. So, to impact of frontline demonstration, what is the impact after conducting the frontline demonstration over the years? So, based on the experience, there is a gap in extension as well as technology. So, this technology gap is existing in the demonstration area. So, in finger millet, based on the mean, so there is a 47% scope for enhancement of yield. Then in foxtail, 29%, Kodo 57%. In little millet, there is a more scope for enhancement of yield to an extent of 65%, 43% in Proso millet and barnyard millet. Next. So the conclusion of this demonstration is demonstrations have a greater role in enhancing the yield. So this enhancement in the yield is not possible only by varieties. It is along with the improved package of practice, agronomy, plant protection, demonstrating we have to work with agriculture departments, state universities and NGOs. So these are all, when we work in cooperation, we can definitely have a success in demonstrations. So this is the final slide. So with this, I conclude my presentation. Thank you all.
Discussion.
Nothing, then I have only one point. As we have already concluded that only the demonstrating the new technology, whether it's a variety or a complete package of practices, it's not sufficient. So suddenly, what are the follow-up actions from our side? Because this year we have made some demonstration. So what is the impact of this demonstration in the next year? Do we have any increase in the area of any particular variety or maybe the crop? For the minor millet, most important is the crop, not only the variety. Because if the crop area is being increased in that particular region, certainly it's a good work. So do we have made any study on this?
Sir, we have made in Karnataka, sir. There is definitely extension of this area is found last year, and also we have encouragement from the government also, since it was International Year of Millets. So, and we also have the what do you call that price, minimum support price for finger millet as plus foxtail millet is also there. That is why even farmers are also demanding more seeds for extending the area.
Very good. So that report also, which is compiled at the institute level or the building level, I think that will be better because that's the real impact of this FLD, not only the minimizing the gap and
In fact, the productivity level is also getting enhanced. That is not reflected in the reports, but the area is also enhanced.
Thank you.
Yes, ma'am. Okay, madam.
We have to include whatever you are saying. It has to be brought into the reports and reflected very clearly that this is the enhancement and this is the area increase.
Okay.
Thank you, madam. Now we will call upon Suganna, Dr. Suganna.
Very good afternoon, respected DDC sir, ADG sir, chairman, co-chairperson, director, project coordinator, XPC, and all other delegates from different centers. I'm going to present the progress report on seed production of the last year. Next slide, please. So this is the breeder seed production of the IMR plus all the ASFP centers. Overall, the breeder seed production across the 6 crops, sorghum, finger, and others, foxtail, little kodo, barnyard, and proso. So in all the crops, there was a surplus production against the DAC indent. In case of sorghum, there was a 200-300 quintal against the production of indent of 132 quintal. And in finger millet also, there was a indent of 68 and production was 120 quintal. In other crops also, all the crops, there was a surplus. Total 48% surplus was there in all the millets. So this is in graphical presentation. Next slide. Yeah, this is related to IMR production. In IMR also, all the production was met, indent was met. So yeah, there was surplus production. Next slide. Yeah, however, there was some varietal mismatch of very minor quantity of different centers like Zivipan, 467A, 11A2, CSV 35F, and these are the minor quantity. There was a mismatch due to one or the other reasons. And in small millets, only one center, especially very minor quantity indent mismatch is there. Yeah, some of the, I think this year the breeder seed indent was finalized and it is circulated through the SATI portal. Already both sorghum and small millet, it is already communicated, and all the centers I request kindly take up as per the indent, and nucleus seed production also should be taken, and monitoring is mandatory. And if any problem is there, suppose, then contingency planning should be taken up so that we can meet the DAC in there. Thank you, Ananda.
The first point is regarding that all the index you have placed through the company portal.
Yes.
So, yeah. So all the index, whatever you have placed through this Sathi portal. So if anyone is facing any problem, just you mentioned that I think most of the you are already in that particular group what we have made for this implementation of the Sathi portal. So if any problem, certainly we are trying to resolve as soon as possible. Certainly it's a new thing. So everything cannot be resolved at one go. So as whatever we are facing, we are getting feedback from the EU. Certainly we are trying to modify the whole of this Sathi portal system. First point. Second, have you seen any breeders index for more than 10-year-old variety?
Yes, some are there.
So what any effort you have made to reduce it if some new variety has come up during the last 2 or 3 years?
New varieties already there. Some like M35-1 still different is there. So
how we can reduce the demand of that particular variety?
Sir, new varieties are like new in Rabi especially. In Kharif we have many new varieties already there recently released. But in Rabi, sir, 29R is there. And state Indian SPV 2217.
Right. Because one thing we must have considered, certainly we are producing more than the requirement.
Yes, sir. Yes.
But our requirement is on the basis of only 34-36% of the seed replacement rate.
Yes, sir. Yes.
And that is not sufficient. But our target is to achieve minimum 50% replacement rate. So just to move to the higher replacement rate, the requirement will be more.
Yes.
So just now, in fact, we are in the surplus. But requirement is more. In fact, they are calculating as per the low requirement. So that has to be considered. And any variety, please talk to the concerned, the center. If the indent is coming from the respective state of that particular center from where we have the new variety, it's a responsibility of that center also to get in touch with the concerned agriculture department so that any old varieties indent can be replaced with the new variety.
Yes, sir. So recently, sir, 3-4 years back, the member in monitoring committee, one member from the agriculture department also included, just to popularize make aware of new variety. That is also there. Thank you, sir. Thank you, Ananda.
Dr. Vikas.
Respected DDG sir, ADG sir, Chairman, Co-Chairman, Director Madam, I am going to present the BSP for Pearl Millet year 2023-24 next. So in response of 10.978 quintal breeder seed indent received from the DAC for 7 varieties and 54 parental lines of different hybrids during the year 23-24. The breeder seed production program was organized for 4 parental lines, 7 varieties and 4 parental lines at SKNU Jaipur, 2 parental lines at AU Jodhpur, 1 parental line at SKRU Bikaner, 2 varieties at Delhi, 6 parental lines at CCS HAU, 2 varieties at Gwalior, RVS KVV, 2 parental lines at JU Jamnagar, 3 parental lines at PAU Ludhiana, 28 parental lines at Criset, 1 variety and 2 parental lines at NARP Aurangabad, 1 variety and 6 parental lines at MPKV Dhule and 1 variety at Amrut Anantpuram. So if there is any deficit in this breeder seed production program, so we plant in summer 2024 and supply to the indenters. So against this 10.978 quintal breeder seed, total 26.953 quintal breeder seed was produced. So this is the situation. So here in red mentioned that This is deficit, but the concerned institute taken seed production program in summer, during the summer, so the seed is available, breeder seed, and supplied to the indenters. So for ICMB 94555, ICMB 94555, both male and female lines of MPMH 35, and similarly 843-22A and 843-22B for HIP 67 improved and HIP 61 improved 2. Next. And these hybrids 843A, 843B and means MH180 is very old hybrid. So it is released by the ICRISET. So the seed production program was not taken. So it is not in cultivation. So we do not take any seed production program. Next. So same case in Shraddha hybrid. That is very old, not in cultivation. It is also susceptible against the downy mildew. So seed production was not taken. Next. Similarly for RIB 15176, but summer they produce and seed is available with us. And same in PA Ludhiana, the hybrid is PHB 114, so it is also very old one, so seed production was not taken. Next. So total 10.978 quintal breeder seeds deck and dent against this 26.95 quintal breeder seed produce. So I am going to present the next stage. I am going to present the tentative DSP first for 2024-25 next. So this year total 16 varieties and 190 parental lines indent was there for different hybrid varieties. So for varieties 7.62 quintal. Next. And these are the deck and dent. We already circulated to all the concerned centers or respective institutes this BSP1 and also sent to the ADG sir, and I am also in touch with the Sripati sir and Chandramohan sir and Srivastava sir because there is a problem of these parental lines, and we also mail to all the concerned officers. So for and we take the action also, and before here I can be circulated to all the centers. Next. So these are the 119. So sir, there is our submission is there is some old hybrid, so we would like to drop it, sir. So I will mail to all the Chandramohan sir and Srivastava sir and you sir, please, because old one hybrids not in cultivation, so we can drop the hybrids, recently released hybrids we have available, so we take these, we consider these hybrids. Next. Next. So total 15 point, so for parental line 7.86 quintal is second time. So total 15.48 quintal is our for variety as well as for the parental lines. This is all about DSP. Thank you.
Thank you, Vikas. So this DSP1 has already finalized?
Sir, finalized.
Already circulated.
Actually ये साथी पोर्टल पे नहीं आएगा सर, क्योंकि साथी पोर्टल पे इसलिए नहीं आएगा अभी क्योंकि पर मिलेट में ये प्रॉब्लम थी कि हाइब्रिड्स का सर जो था वो प्राइवेट का टेंडर वो तो मैंने
राइट बट ओपी को तो डाल सकते हैं।
ओपीवी का सबमिट कर दिया सर पुलिस सर, साथी में सर दोनों ही जाएगा। श्रीपति जी ने बताया था कि अगर जाएगा तो वो दोनों ही जाएगा।
नहीं क्योंकि पर मिलेट साथी पे नहीं आया है पूरा।
इसके सर रीजन ये उसका काफी बार 3 बार मीटिंग कर चुके हैं, हमने सबके साथ कर दिया।
Okay, we are trying to resolve this issue of the parental lines को कैसे उसमें डालते हैं। साथ ही से we are regularly meeting with the NIC person and all the concerned person. Hopefully we will resolve it quickly for the inclusion of the parental line instead of the hybrid. Because most of the cases the intent we are getting for the hybrid, not for the parental line. That is a major problem. Another point, in fact, so you must write the year, in fact, for all the seed. So must write year also in there, so that it will be clearly visible that this whatever the variety you are giving, this is the how old.
Sir, in report we mentioned it. In report,
I understand report you mentioned it, but here in the presentation it also is one column.
Definitely. सर इसमें सर हमने जितना भी हमारा काफ़ी सेंटर से सर इंस्टीट्यूट से आया है कि हमारे पुराने हैं तो उनको हम वापस से
नहीं फाइन सो इवन इफ some center is saying that these varieties are quite old or really it's not in demand. Though indent is coming for the few, only very small quantity. And if they are unable to produce, whatever the BSP2 they will report, we will consider the whole further process on the basis of that BSP2. So please ensure to provide all your information in the BSP2, what you are planting and what you are not taking up, that you must clearly show in your BSP2.
ओल्ड है वो तो सर वो जैसे काफी ओल्ड हाइब्रिड आ
Sir, many times very old variety indent is coming. That should be reduced. That should be deleted at the level of project director or director itself. Otherwise, what happens is there is no seed available and it is a pressure on the organization, producing organization to produce that seed. So better to tell the intending agency through the director that it is a old variety, it can be replaced by this variety. You kindly place the indent for this new variety. I think that will be better.
Normally we take up this point. In fact, when we finalize, we have this finalization of the breeder seed intake for both the Rabi and Kharif season. We take care of this. But in fact, sometime really some state government, in fact, they pressurize that this particular variety, though it is old, but is in the high demand. And that time it's really difficult. But if the quantity is very small and the variety is very old, certainly we will not include that in our seed.
एक्चुअली सर हमारे यहाँ की कई सारी लाइन है जो कि इस बार रेट का है, काफी ओल्ड हाइब्रिड सर जो कि अभी चेन में भी नहीं है। दूसरा इसी है कि यूनिवर्सिटीज में इतने आइसोलेशन नहीं मिलते कि हम इतना मतलब आइसोलेशन से भी सीड प्रोडक्शन ले सकें। तो जो हाफ केजी या 1 kg सीड है वो एज ए न्यूक्लियस सीड हम प्रोवाइड करा सकते हैं। बाकी ब्रीडर सीड में जो आइसोलेशन है वो अवेलेबल नहीं है। तो एज ए न्यूक्लियस सीड अगर हम देना चाहें तो
नहीं, ऐसा है कि जब यूनिवर्सिटी के अगर दुर्गापुरा दुर्गापुरा में आइसोलेशन की कोई दिक्कत नहीं है, बहुत फार्म है। दूसरा यूनिवर्सिटीज के दूसरे फार्म है, अगर वैरायटी आपकी है, इफ यू आर डेवलपिंग वैरायटी, इट इज योर रेस्पॉन्सिबिलिटी टू प्रोड्यूस ब्रीडर सीड, एंड इफ द वैरायटी इज न्यू, इट्स इंटरेस्ट ऑफ योर यूनिवर्सिटी to meet that small quantity also, because for old it's a fine, we will reject the small quantity. For the new variety, if something is coming, because to get popularized in the coming year, you have to produce that small quantity also. Yeah, because you will remove the new variety from the seed chain, then how will it get? You will get more indent in the coming year.
No sir, new hybrid we can give the new hybrid parental line, but I am saying for the old parental line.
सर काफी ओल्ड आ गए सर, 10-10 साल
20-20 साल 15 साल ओल्ड जो लाइन।
हाँ नहीं, ओल्ड ओके, लेकिन अगर ये आपके स्टेट से है, इफ इट इज कमिंग फ्रॉम राजस्थान, आप अब राजस्थान गवर्नमेंट को क्यों नहीं जाकर मिलते हैं कि इसकी इंडेंट कम करो, ये हमारी दूसरी वैरायटी है, ये उसको लो। आप सिंपली काम आपका इससे खत्म नहीं हो जाता कि नई वैरायटी हमने दे दिया। अगर स्टेट जहां आप हो, जिस स्टेट में हो, अगर वहां से इंडेंट आ रहा है, आप क्यों नहीं खुद मिलते हैं अपने और दूसरे लोगों के साथ मिलकर कि इसका इंडेंट आप कम कीजिए। एटलीस्ट यू कैन हैव प्रेशर ऑन योर ओन स्टेट।
नहीं सर, ये जो इंडेंट है स्टेट का इंडेंट
नहीं, स्टेट इंडेंट है, स्टेट इंडेंट है, इंडेंट तो स्टेट का आ रहा है, इंडेंट तो स्टेट का है, ये क्या राजस्थान का नहीं है इंडेंट।
नहीं, ये हाफ केजी जो ओल्ड हाइब्रिड
ओल्ड वैरायटी भी है, इंडियन किसी स्टेट का तो होगा,
राजस्थान स्टेट का नहीं है सर।
राजस्थान का नहीं होगी वो सब इसमें है सर।
BSP1 में क्लियरली आप लिखते हो कि किस स्टेट का कितना है
सर। वो अभी इनको हम भेजेंगे ना सर, वो भेजा भी है इनको सर। उसमें क्या है कि
नहीं, उसका ब्रेकअप आप जरूर दो कि किस स्टेट का इंडेंट है, और NSAI प्राइवेट का इंडेंट है, किसका इंडेंट है, ये
मैं भेज।
Sir, myself is Dr. K.J. Gujra from Jamnagar. Same is the case with the Jamnagar. Very old, I think 16 years old hybrids, and indent is very less. Further, this hybrid is also becomes susceptible to downy mildew. So what is the meaning of intending such hybrids parental line? And from where this is the indent, Dr. Vikas?
सर अभी इसमें मैंने आपको भेजा भी है, अभी भेज दूंगा दोबारा आपको, क्योंकि उसमें जितने भी इंडेंटर हैं उनका लिस्ट में मेरे पास लेट आया था, तो मैंने DSP कंपाइल करके आपको
Second, the time is very less because we have got that Indian circular just before I think weekend.
Yeah, 25th.
And the supply is February 25th.
Yeah.
So time is very less because in this our Gujarat we are producing this breeder seed in summer season.
सर वो हिस्सा भी हुआ है, इसके लिए सॉरी नेक्स्ट ईयर, क्योंकि थोड़ा सा साथी पोर्टल थोड़ा सा हम कर रहे हैं तो उसके
Anyway, because you just note down all these things. Wherever this type of the situation is, you must talk to them or you write to us. Okay, we will talk to the concerned.
Sir, same is the case with the PA.
Ma'am, mail ready. Okay.
Okay, thank you.
Thanks.
Thank you. Now I will call upon Dr. Ephraim.
Chair, co-chair, audience, I'm going to present research collaborative research projects that were implemented in 2023-2024, and after this I present also the work plan for the year 2024-25. There are three major projects. The first one is on genetic improvement, dry-land date cereals, improved adaptation, yield potential, and quality traits. This is specifically concerned with accelerated crop improvement and supporting other disciplines. The second project is on biotech traits, new breeding techniques, and enabling technologies for dry-land cereal crop pipelines. And the third project is on integrating systems analysis and modeling the tools to identify interventions that enhance farming system resilience and nutrition-sensitive agricultural value chain. Next. So the project one, I try to present salient achievements, and I would say that at ICRISAT, Millet saw 3 varieties released using ICRISAT bred materials. While in sorghum, we had 5 sorghum varieties that were released nationally using ICRISAT bred parental lines. We were also interested to see how ICRISAT is contributing to the improvement of genetic again, and you can see on the right side of the screen that we have encouraging data on grain yield and fodder in the covered years. Next, please. Also, we observed a very interesting, encouraging genetic gain in terms of grain mold resistance and shoot fly resistance in this number of years we observed this trend. Next, please. All these data on genetic gain are supported also by the observed yield advantage. As you can see, in the last 7 years until the year 2023, we observed these things. Next, please. So, in terms of new genetic materials we share with us, as you know, ICRISAT mandates include, among other things, to share technologies, including also new materials, superior materials, with our NARS partners. So, in the year 2023, we exchanged more than 7,000 breeding lines, more than 62 resistant lines, and more than 500 trait lines, and more than 33 populations. Particularly, GeneBank has applied more than 28,000 seed samples, including nearly 600 sorghum, 500 perry millet, around 800 finger millet, and more than 1,500 small millet were distributed to our partners here in India. Next, please. At ICRISAT GeneBank, we are working on establishing diversity representatives subset, I mean core and mini core collections. You can see all these crop species that were covered, including perry millet, around 238 size of the sample, and sorghum around 242 the size of this cone. Next, please. We are also at Gene Bank establishing trait-specific subsets in order to support breeding programs across the country. You can see that in the finger millets, for example, we have around 22. In sorghum, for example, we have around 91, and we have more traits in the finger millet around 118. And I think we received the presentations presented here in this forum, and you can just check also the links linking to the data that are just cited here. Next, please. We continuously run maritime environmental trials nearly each season, including Kharif Rabi season. And in the 2023-2024 rainy season, we ran more than 1,500 experimental plots in more than 80 environments in this country. We had a total of around 76, in sorghum, for example, we had more than 400 total of experimental plots, and near 1,000 plots for pillar millets, and around 50 experimental plots in the finger millet. Next, please. In terms of innovation to enhance genetic gain, as you know, genetic gain can be estimated on our research stations, but now we are trying to estimate genetic gain on the farmers' field. This project is just in finalization, and we think that by next year we'll be able to run genetic gain assessment on the farmers' field. And this is particularly important, and I urge all of you to try to collaborate on this effort, because this is maybe the only way we can assess the gap, the yield gap, and then find information to help us reduce this gap yield that we continue to observe. We are at Research implementing index-based selection nearly across all research mandates, and we have seen that index selection can work very well both for qualitative traits and quantitative traits. We are also implementing a rigorous, robust discipline in breeding programs, particularly in terms of how we select a parental line for running crossing blocks. Some of the key criteria to select the parental lines include general combining ability and genetic distance using particularly molecular marker information. We are decreasingly relying on popularity of parents. That was the major criteria in the last years. In terms of data quality, we are quite frankly concerned about improving the quality, because this is the only way to formulate accurate recommendation to the production environment. So we are taking serious measures in this regard. For example, in sweet sorghum, for the last several years, we used to harvest above ground biomass sorghum using knife in the hands, and 2 hectares particularly could be harvested maybe in 1 month. But now we are introducing the forage harvester that can be used for both sweet sorghum or forage sorghum, even dual purpose sorghum. And with this forage harvester, you can harvest 2 hectares in less than 8 hours during the day. Next, please. We are also improving our phenotyping and screening capability. You can see that the screening for down video is just being completed, also blast in a pyramid. We are also using proximal and remote sensing tools, including drones, even sensors, optical sensors particularly. These are high throughput. You can just phenotype even 10,000 plots in a matter of 1 day, which is remarkable. Next, please. In terms of pathogenic variability, in approach isolates in finger millet, this is in completion, and the standardization of host host differential sets is also in completion. Next, please. In terms of genomic tools and root architecture, we have made very significant progresses. We are implementing mainstreaming quality control markers for controlling hybridity confirmation. This is particularly important to run crossing blocks because we are observing that when we run the QC markers, usually we can come across 40 to 50% false hybrid cross seed, which means that QC markers running is a must-have to have accurate crossing blocks, because in several crop species it can be very hard to differentiate between the progeny coming from true crosses from those progeny coming from false crosses. We are also implementing mainstreaming mid-density assay in ICRISAT managed crops, and this mid-density will serve several purposes, but the major one we are starting with is genomic selection, and in several of ICRISAT mandates we are just building the training population, and we hope that in a matter of 2 or 4 seasons we will be mainstreaming this genomic selection by even predicting the genetic values, genetic merit of the candidate selection, and by passing maybe stage 1 or stage 2 trials. In terms of root architecture also, as you know, this is a very difficult trait to phenotype, but we are making progress here using collaboration, particularly with our European partners, and we are able to do this in a high throughput way. We have recently uncovered even some response to the stay green trait because root architecture happens to be a better explanation of stay green and drought resistance, particularly terminal drought resistance. Next, please. In pure millet, we always in genomics tool technology. We have completed 3 platinum grade quality genomes with 7,000-fold beta counting N50 generated in pure millet, and we hope this discovery will help improve pure millet genomes representing global heterozygous pool, and this will offer a framework for molecular breeding applications in these crop species. Next, please. So it's always here in finger millet, screen not very visible, but this is finger millet genomics. We have started the blast resistance assessment using genomic tools and nutritional trait assessment using genomic tools, and we have completed whole genomic sequencing with a very big amount of terabyte data, and this will help in terms of molecular breeding efforts, not only at ICRISAT, but also across our partners. Next, please. The second project is on agricultural traits, and you can see that we can start with rapid generation advance. We are making really progresses, and during this conference I've been discussing private companies and the public institutions. It is very good to collaborate in this effort, and many of you can learn from us, even take technology from us to improve your work back at your institutions. We were able to learn from progresses in finger millet rapid generation advancement, and this lesson learned from there helped us to improve, for example, the rapid generation technology in other crop, including pulses. Next, please. In terminate proper, we were able to reduce or to gain nearly 2 seasons under rapid generation advancement. Next, please. In terms of new breeding techniques, we are trying to make progresses to address acidity in the pure millet in order to enhance flower shelf life. We are at the start, but the preliminary data show, for example, that we are just again mastering the regeneration techniques of this crop, and the work is still underway, but we are hopeful for the meaningful outcome. Next, please. Always in gene editing, we under the funding from DBT, we are editing in sorghum, particularly sweet sorghum, high biomass sorghum, in order to see how we can improve, optimize the lignin concentration in sorghum cellule in order to improve the digestibility and consequently improve the process yield. Process yield, be it in terms of biofuel production or be it in terms of animal husbandry, because the process yield is nearly almost similar, and we have observed encouraging results in introgressive line, BMR 6, BMR 12, and now we have a product of pyramided mutations, and this project I'm running it myself with the help of 3 PhD students, and also the results are encouraging. Yes, please. Yeah, these are the pyramiding of BMR 6, BMR 12 using alternative genetic means. And also here we are nearly at the 4 L5, and this line can be exchanged shared with our partner. Next, please. The third project is on systems analysis and modeling, and we are conducting this investigation across India and millet value chain in the country. And what we have gained as outcome is the insights that were generated across this value chain continuum will be particularly valuable to operationalize the roadmap to promote millet for sustainable agriculture in India. Next, please. In terms of mainstreaming modeling tools and more promoting sustainable resilient agriculture, I think we are meeting our goals on whole farm bioeconomic modeling and multidimensional sustainability assessment in the effort to design sustainable farming systems. And we are also mainstreaming intelligent systems advisory tools to deliver context-specific climate agro advisory. I think at IFISAT we are quite advanced in, as I told you previously, in proximal remote assessing, either using handheld sensor or drones, or even using the constellation of satellites, and developing handy apps that can be used by non-experts. Next, please. In terms of capacity building, particularly if we start with students, we have trained around 117 research scholars, and more than 300 interns and fellows were trained at IFISAT. Next, please. In terms of key capacity building program conducted in the 2023, what I can say is in terms of demography, we had 62 females and 84 males were trained at IFISAT in this topic, and you can see on the left hand of the screen. Next, please. Now I will go very quickly in the work plan 2024. Please. So the program 1 is on accelerating genetic again for yield, disease, pest, resistance, nutrition, and climate resilience of millets or millet pulses and oilseed crop. Next, please. The second program is on bridging the yield gaps I was talking about previously in the drylands through climate proofing and landscape approaches. All these techniques will be combined, and we are looking for a very good financing of this activity starting from the year 2025. Next, please. The third program is on value chain development, agribusiness, entrepreneurships, and smart food. At IFISAT, this activity is of great importance because this is one of the factors of adoption of millet, because as we also discussed lastly in the brainstorming organized by IRBAR, one of the key factors of adoption is having recipe that can be adopted not only in India but continentally across developing countries. Next, please. The fourth program is on emerging science and technology. Here we are talking about gene editing, as I was talking about shelf life millets, for example, or identifying allergic variation and the candidate genes in equivalent mandates, and the functional validation of allergic variations in identified through sequencing techniques. Next, please. The fifth program is on capacity development and cross-cutting areas, like, for example, gender equality, social inclusion, monitoring, evaluation, learning, and impact assessment. Next, please. Yeah, I'm at the end. Thank you very much for your attention.
Thank you. Thank you. Yeah, thank you for presenting all the views, all the whatever our international partner ICRIS is working in the different aspects of this millet. So any queries and questions from that?
Yeah, very good presentation. Congratulations. Your work also is in a good way what we want. So my suggestion here is that I find that you have your new breeding techniques you have used to develop varieties, particularly for grain mold and downy molding. So grain mold, you know, is a very difficult work in case of sorghum. So my suggestion is that you please share the material, your success with our counterpart, so that they don't have host plant resistance for this grain mold. You have a global collection, so you can have that. You have successful example you showed in your first slide, and that also I request you to add that in your work plan also for novel sources of resistance for grain mold. We are not getting actually the host plant resistance here, particularly in India. Our team, they are facing difficulty. You will be having global collection, so please take care, and thank you. Thank you very much.
If I can comment, thank you very much, sir. I was talking in the margins of this conference about, for example, our great achievement in several areas, including the universal restaurants, for example, and in other areas. I was hearing this morning about fruit fly. We have good markers on fruit fly that can help early generation selection. This is very important. And when I talk with private companies, for example, because private companies can be helping the country in terms of extension services when their varieties are just going to the farmer, because private company also can just reduce spending on pre-breeding by joining the ICRIS Research Consortium, and because we have the tools by the means of economy of scale, we happen to spend more than private companies if we do the job, because we are doing it at scale. So I think we can help both private companies and public institutions at a significant level. Thank you.
Thank you very much for a very good presentation and good work. I was really happy to see that the standardization of post differential set for blast for finger millet. Would you be able to spare some seeds of these differential sets?
Yeah, absolutely. What I will tell you is ICRISAT, by our mission, our technology is open access.
Okay.
So we can share everything.
And second is regarding your value chain, this thing. I was very surprised how you are covering pan India, but you have left to Uttarakhand, which has a sizable area under finger millet. So my request would be you kindly include that also so that your picture is complete. Thank you.
I took a note of it.
Very good amount of work is being done at ECOSAT related to downy mildew and blast pathogen variability studies. On behalf of the ASR and pearl millet, I request that the host differentials of downy mildew and blast be shared with us so that we can also strengthen our research programs. So we will, many times we have requested, but still we have not yet received it. So again, in this auditorium again, I am giving you a request that you may kindly share the host differentials for downy mildew and pearl millet blast for both downy mildew and blast pattern.
Yeah, this is also director. I promise we will respond. Yeah.
Thank you, Dr. Ephraim, for a nice presentation. Sir, everybody here, Honorable DDG, ADG, Madam, I am Hyderabad in director is there. So this is my one submission is that we have two projects that Madam collaborated with the ECOSAT because our state is concentrated only finger little millet. From this year onwards, we are having two projects on non-nagi millets. So all are there. So I submitted that if we allow the materials developed by us in Odisha in multiplication trials, as it is going on in the Parliament and sorghum, it will be better for us. And the thermal communication will come from research, research sites. So.
If you want to have that first send us a mail because already the allocation of trials are complete. The allocation of trials.
Allocation will be completed and we have started our work this college season.
We will take it up next year. And next year onwards we will include. Already this year complete.
Okay, no problem. Thank you.
Yes, you have conducted this you did not inform anything to the PC unit.
Just now, sir, just now.
Last year, this year also is there. So you have to inform, no? So you are our staff and this is our center. You are continuing.
I got the allotment and I communicated.
You not communicated. You have to take our system confidence actually.
So that's
every agent we are telling this, but still it is repeated.
No, last year I told you what I could not take this trials and all these.
No, without the.
There has to be a formal communication to the PC.
Yes, that is.
Yeah, very good point, Dr. Madhusudan. Certainly, in fact, we have seen our Honorable DDG is here. So we have seen in the other crops also. In fact, the center is directly corresponding or directly making lots of things in the other crops also with the ECOSAT. So that should be avoided and please come through the system only. Yeah.
No,
it's a fine, yeah.
Maybe can I add something here because in addition to heading some breeding activities, I'm also in charge of my environmental trials there for all the crops. So what we start doing since I assume this role is to build a project, and this project we'll discuss it with IMR because even in the previous years we discussed it with you. And you justly told us that the testing centers are overloaded, and this is true. And we think that this project can help us solve this problem and improve our collaboration, particularly in environmental trials, because we can inject money to support this activity. And I think this can be a win-win situation for all of us. Thank you.
Respected chairman, co-chairman of this session, I'm honored to have the Honorable Deputy Director General Crop Science and Honorable Assistant Director Science General of Food and Fodder Crops among us. Among the dignitaries, I will be presenting on intellectual property management of the institute, and which is extended to all the AICRPs in my slides. I will be taking very less time because I know that everybody is waiting for lunch, and I will be talking on technology identification, technology protection, technology transfer, and technology commercialization. So the motto of this unit is to transform the millet research into products and services for the benefit of all the stakeholders. So every research should end up in a discovery, or it should end up in an invention. That invention should be disclosed and it should be evaluated properly so that we can protect it with the different aspects of intellectual properties, be it a patent or a copyright or anything like that. Then when it is being protected, it can be marketed by marketing, by selecting a partner, or commercializing the products and services for the benefit of all the society. Through commercialization, some kind of revenue can be reinvested into the research. So the cycle goes like this by transforming the millet research into products and services. So technology, as we all know, it could be a product or a process. It could be from today in this context, collaboration and collaborative technology development is the need of the hour. So we do have collaborations with different centers, with different institutes, private organizations, and even FMGCs. The AICRP is the best model for collaboration because we do have AICRP and Pearl Millet 13 centers and 18 centers in AICRP in Sorghum and 13 more centers in small millets. Apart from that, there are so much collaborations with different agriculture universities, organizations for millet promotion. So these are the different MOUs we have done. I will not go and go in deep. But these collaborations are very much needed. I will give only one example. We know leaf color chart in rice. Likewise, we have collaborated with nitrogen parameters to make leaf color chart for sorghum, pearl millet and finger millet. We could able to do within a year this thing only because of collaboration. If we can do, that will take a long time. That's what the importance of collaboration. So technology could be a cultivar or advanced agronomic practices or plant protection technique or millet value added products. So when the technology is identified, it has to be properly protected. So be it a patent or a copyright or trademark or even geographical indication and any other thing to be protected properly. So these are the different patents we do have at the institute level. Not only the patent to be filed, it has to be commercialized. So I am happy to tell that all the patents which are filed are commercialized. Even we do have commercialized to 18 companies the patent number 2, that is the preparation of flakes from sorghum. So apart from patents, that could be different things like trademarks. We have immediately when the institute was renamed as Sri Anna Institute, we have trademarked that logo. Apart from that, we do have trademark of Eat Right. Eat Right is our trademark. Eat Right Jowar, Eat Right Bajra, Ragi, Proso, Foxtail, Kodo, Little, Barnyard. And when this all are branded as Sri Anna, we could able to immediately file a trademark for Eat Right Sri Anna also. So this slide I wanted to just sensitize people that geographical indication is one of the important things for promotion and branding. Total there are 643 geographical indications. Among that 201 are for agriculture goods. Among that we have only 6 geographical indications related to millets. If you see that Maldandi Jowar or Dagdi Jowar or Uttarakhand Madua, Uttarakhand Jangora, Arunachal Pradesh Agnet Millet, that is a job steer millet. Arunachal Pradesh Maru Apo, that is a wine made of millet from Arunachal Pradesh. These are all the geographical indications which have been already registered. If you see these things, except the Maldandi Jowar that was registered in 2014, all others, name it Dagdi Jowar or Uttarakhand Madua and other things, all the five GIs are registered just previous year. So the things now it is to be taken that exploiting this registered GIs, branding it and make products out of it and make it into the market is the most important part, which is lie on us. So there are so many copyrights, I am not going into it. And these are the different cultivars. Definitely it is the most important technology which is coming out of this AICRPs, the cultivars of hybrids and varieties of pearl millet, sorghum, finger millet, foxtail millet, kodo millet, barnyard millet and proso millet. These are the cultivars identified in the previous AGM. So the technology is now generated and protected. Now how to extend it, how to transfer these technologies to different parties. Of course, transfer of technologies to farmers is very much free, and we have seen FLDs and other things, demonstrations. We are giving directly to the farmers because our goal is to improve the millet production and cultivation in the country. But for technologies which can be commercialized through seed industries, we do formulate MOAs for 3 years. We license these technologies, the hybrids and varieties. Hybrid license fee is about 5 lakhs plus GST, and the varieties it has been licensed with 3 lakhs and GST. There is a royalty, and what we are doing also it is given here. And recently we are through AgriInnovate also we are licensing CSH 43MF for MOA with 5 years with 15 lakhs license fee. So this is a gist of what are the things which has been done last 5 years. From 2018-19 onwards, you can see CSH 24MF, CSV 33MF, SPV 2018, and CSH 30, CSH 22SS, and many other, CSH 41 and CSH 39 are also licensed to different seed companies. There are about 32 seed companies which we have licensed with 8 cultivars with a revenue of 165 lakhs. You can see here the CSH 24MF is licensed to 20 companies. CSH 43MF, which is a replacement of 24MF, is being licensed to 4 companies, and many other things are in line. And CSV 33MF, which is licensed to 2 companies, and CSH 41 is licensed to 4 different companies. So it's a proud here that many of our fodder varieties are going to the market through the seed companies. So this is what it has happened in 2023-24. We had 6 licenses, of which 4 are for CSH 24MF and 2 are for CSH 41, and there are so much of EOI expression of interest for CSH 43MF also. Since it was there with AgriInnovate, we are able to do it slightly bit slow, but we are on the line. So come to that benefit sharing, that as I told in 2023, from January to December, we had 6 MOAs made with the different companies. We got 28,50,000 as a license fee, and the royalty from Advanta Seeds, royalty from Rasi Seeds and Maiko Private Limited, we could able to get 11,90,917. So this a total revenue of 40,40,917 is taken, excluding GST and income tax. So this has to be distributed among the partners as per the ICR IPTM guidelines. So the categories goes like this. The ICR headquarters will get the 15% share. ICR Institute, that is IMR, will get 40%. The innovators, for example, for this CSH 24MF, the one parent is from GPPVAT and one is from ICRISAT, which is bred and developed by GPPVAT. So they are also as innovators there. They will get a 20% share. IAMR staff welfare and ICR staff welfare also get 2.5% share in it. So a total for 2023, ICR IAMR is getting 3,80,000 GPPAT Pantanagar is getting 8,24,245 rupees and ICRISAT is getting 4,12,122 rupees. So this is what we have to distribute today. I'll come to the last previous one. So come to the next technology of millet value-added technologies available for commercialization. At the institute we do have 66 different technologies. All are millet value-added technologies, be it mixes, instant mixes like pongal mix, khichdi mix and other things, be it atta, multi-millet atta and many other things, cookies, pasta and vermicelli and many other things are being developed and ready for commercialization. These are the information on that. On commercialization, we will be giving technology training to the licensees with 1 or 2 representatives. We will be making them to understand how to make this product, and we will be giving a technology docket with the details of machinery specifications and the suppliers of the machinery itself, and also the nutritional profile and the shelf life will be given to the licensees so that they can go and do mass production and sale of this millet technologies. Among these 5 years, we could able to license these technologies to 41 companies and startups with a license fee of 49.94. So in 2023 and 24, we could able to license these different millet value-added products to 11 different companies, which is listed here. About 63 different products have been given to 11 companies with a license fee of 19,63,520. So in a conclusion, as I told, research has to end up in an invention. Invention has to be properly protected. After protection, it should be commercialized and so that the benefit can be extended to all. So here we are committed for technology identification appropriately, protect it properly, and transfer it efficiently, and commercialize it effectively. Thank you.
Thank you, Dr. Stanley, for sensitizing this IPR management and commercialization issues with the entire this group. That is the need of our, in fact, because we have to generate resources. Money is, in fact, the most required input. In fact, as we have discussed in the past session also, the government is also asking to generate your own resources. That's it's a better way. So whatever the technology or the process or anything you have developed, you must go for the commercialization, and this PC Unity ICRP is ready to help in the every this aspect, production, either the production of the IPR, whatever you have developed, or the commercialization. So better you contact and directly be in the contact with the IIMR for your whatever the product you have developed. So with, thank you very much. So final. So with this, we end to this session, that is outreach and the seed session, including this commercialization and the IPR. So I'd like to thank all of the presenters, all the participants, and all our dignitaries sitting here, Honorable DDG, ADG, and I'd like to thank the organizer to giving me this opportunity to share some of my views and the concern, mainly respect to the seed, but certainly some other aspects, outreach program also. Thank you very much to all of you. Thank you.
Thank you, sir. As we are concluding this session, outreach activities, seed production, IPR and ICR partnership trials, we thank the chairman and co-chair of this session, Dr. Sanjay Kumar, Director, ICR-IAS Mavu, the chairman of the session, and Dr. T. Lakshmi, Head Agricultural Extension, SB Agricultural College, Tirupati. We also thank all the speakers of this session, Dr. Manoj Kumar, Dr. R.R. Chapke, Dr. T.S. Sukanya, Dr. D. Suvina, Dr. Vikas Khandilwal, Dr. S.A. and Dr. J. Stanley. The reporters of this session were Dr. Sangappa from IAMR and Dr. G.M. Kote from Parvadi. And
Now, I may request Dr. R. Madhusudana, Project Coordinator, Sorghum and Small Millets, to kindly felicitate the chair and co-chair of this session.
కెమెరా వస్తుందా?
రావాలా నువ్వు ముందు జరుపుకున్నావు ముందు మనసు
దీనికి కొంచెం జూమ్ లాక్కో.
Thank you, sir. Now we are breaking for lunch. We shall assemble here back at 2:30 p.m. for the special lunch. We request you all to be back sharp at 2:30 p.m. for the special lunch. Thank you.
अरे भी वो गाड़ी जो जा रही है मुझे छोड़ने एयरपोर्ट जाएगी अभी छोड़ने चेक कर लो और उसी में डाल देना वैसे रहने दो तो ये मिल गया ले लिया फोटो आ गया और क्या चाहिए फोटो भेज देना कल वाले फोटो
सर वो सार के नहीं मिलते हैं सर, ये सार के नहीं मिलते, ये सार की टोटल डेटा साथ
along with some materials are which is kept in this auditorium. If anybody could able to find it out and give, that would be clearly some material along with the
చిన్న రాలే వస్తుంది జిప్పై కోడి వెళ్ళిపోయింది పక్కకి చేయను కాలర్ మైక్ అడిగింది మైక్ పెట్టుకోండి సార్ మన కదా సో నోబడి ఓకే ఈ నెట్ కనెక్షన్ కాబట్టి కొంచెం టైం పడుతుంది నువ్వు ఊరికి ఫోన్ చేసేసి రాలేదనా ఏదో ఫాస్ట్గా వచ్చి వచ్చేసింది పెట్టి అయ్యి కెమెరా అసలు ఫోనే చేయండి అయ్యి ఉన్నాడు.
Good afternoon. We are resuming our sessions and now we will start with a special guest lecture. To start this session, we would request Chairman of the session, DDG Crop Science ICR New Delhi, Dr. T.R. Sharma, to kindly be seated at the dais. I also request the co-chairperson of the session, Dr. C. Tara Sativali, Director IAMR, Project Coordinator for Millet, to be seated on the dais. The rapporteurs for the session are Dr. Jinu Jacob and Dr. Parashram Patroti from IAMR. The special guest lecture is to be given by Dr. Ishwaraya Rami Reddy. We'll have a brief introduction of our speaker today. Dr. Ishwaraya Rami Reddy is working as an associate professor at the Indian Institute of Science, Education and Research, Tirupati. Dr. Rami Reddy obtained his bachelor's in agricultural sciences from Acharya N.G. Ranga Agricultural University. After his post-graduation from the University of Hyderabad, he did his PhD at the Freie University, Berlin. After a brief stint of postdoctoral experience in 2011, he became a group leader and led a root biology research team at the Department of Applied Genetics, Freie University, Berlin, until 2016. From April 2016 onwards, he started working at the Indian Institute of Science, Education and Research, Tirupati. His research interests include plant root and rhizosphere engineering to design the roots of climate resilient agriculture, molecular plant pathogen host in racton, crop improvement through genome editing technologies, and so on. He has a lot of publications to his credit, and Dr. Rami Reddy sir, we are privileged to invite you for this guest lecture. And to begin the session, we shall hand over to the chair of the session. Thank you.
Good afternoon to all. On behalf of co-chair and myself, I would like to welcome you all for this very important and special lecture by Dr. Ishwara Reddy, who is molecular biologist and experts in many areas of post-pathogen interaction and root biology. So I think this is a very good opportunity for all of us to see what type of work or basic work one is doing in India and how it can be applied in various crops so that we can protect our crops from biotic and abiotic stresses. So we are already late in this particular session. I request Dr. Rami Reddy to kindly deliver the talk, and I think 25 minutes are on.
Thank you very much, sir. Thank you. I hope I am audible. Yes. Yeah, thank you for organizers for inviting me over here. Actually, I learned a lot on how much of work you guys are doing over a period, and then I always have a huge respect for all of you who are all the field scientists who are really contributing to the agriculture field so much to our country for our growth. So I will try to see that within next 20-25 minutes what kind of research we are doing in either Tirupati, and then first myself and later on few of my colleagues. So I gave my title as a root and rhizosphere engineering. Can I? It's not working from here. Here also now. Thank you. Yeah, it seems like that. Please, next one. So most of the time, my thematic area of research is confined into different areas, both on below ground and above ground parameters. And then I had a huge collaborations with the present Agriculture University and ICR Research Institutes. Without that, it is not possible to translate anything to the field, I believe. So that we had a strong collaborations in that aspects. I will just briefly touch on that. Next, please. So as you see, my journey started like 2011, explaining that cytokinin, a phytohormone that regulate root development, and then it's a negative regulator. And then we use this basic principle. We publish a lot of papers on what is the mechanism behind it, and then why it is a negative regulator, how it is controlling root system architecture, both primary root, lateral root development, and others. So next, please. And using this basic principle, and then we understand like whether we can translate this knowledge to croplands or not. And then what we did is we try to utilize this knowledge and increase the root system architecture in barley, and then also in maize, in brassica, and then in each time we use a different set of specific promoters, either root specific promoters or nutrient responsive promoters or stress responsive promoters, and ask the questions whether an increased root biomass, an increased zinc can really helpful for the plant to upgrade and to its performance. We show that it can be increased iron and zinc even under field conditions. We did a GMO field trials in Czech Republic, even it is in European. Then we even sell this patent to a private company, Limagrain. And then at that time point, and then even though we have all these points, when I came to know that most of the things that we do in the laboratory, which is a foolproof in a greenhouse conditions, and then we can very well show over here, not 100% is not going to come true in field. So there is a lot of differences which you are all well aware of that, even in our MLTs and others, wherever one where like morning some are pointing out that the checks, they are normally utilize it, they are not performing very well in one area than others, which is normal, which is we already know that phenotypic plasticity and inherent genetic potential will vary across the environments, and then it is peak and long. Next please. So we now understand that how a particular plant and others communicate to its neighbors. Here neighbors means it can be abiotic factors like soil edific factors, and then metals and other kind of things, or biotic factors, microbes and others. So we want to interest how this communication is happening. If we can able to decode this communication, whether we can able to understand how come plants behave differently from one area to another area, how they are integrating the environmental signal into its growth and development. And then at the same time, plants are also not only have friends but also enemies within the underground, how they are trying to enter into the plant root system and thereby destroying the crops. And several research questions that we are interested in, and then one by one I will try to explain it. Next please. So when I was trying to understand that the first root system or the first root tissue that is undergoing into the soil is the root cap. And then as you can see over here, root cap structure is different across the taxa. In the monocots or in the dicots and others, the number of layers, number of cells, and they are so vary, but this is the root cap that is act like as a drill, and then it is the root cap that is communicating with the microbiome, that is the root cap always going away from the toxic environments, being it salt, being it metals, also trying to going away towards the direction of water and nutrients. Now our interesting question comes, how does, particularly in Arabidopsis, it comprises around 150 to 200 cells, how such a small number of cells or one or two cell layers can integrate this much of information and then try to defend the plant from various factors. And then we nicely drawn upon different kinds of crop plants like rice, tomato and maize, and then what are the factors that are there at the root cap specific level. Next please. And we now at the developmental basic research level, we are understanding about it, what are all these receptors, signaling, transcription factors that are underlying these principles about growth, differentiation and others. Whereas for this audience, what is more interesting is we are now looking for how that external signal, being it is a salt, being it is in a heavy metal stress, or being it in a biotic stress, how this root is going to depend, or particularly this root cap is going to be dependent. So for that purpose, what we did is, we try to understand when a particular root cell is there, normally there are 16 different cells are present, cell types are present. When a particular bacteria or anything, when it is trying to enter it, it has to pass through one layer by another layer until it reaches the vascular system, particularly milk pathogens and others, or any other organism, in order to spread. Now, each cell layer in the root will mount a different kinds of a defense. For example, the moment when it is touched in perception, calcium signaling and ROS spiking, you can normally even record it now from one cell file. The moment it is touched in epidermis or later root cap cells, then internally already the endodermis, you can see huge calcium spiking or ROS spiking. So the signal passes to the neighboring cells, okay, something is coming, before be ready or try to defend it. So now we want to understand how exactly this cell by or cell type specific regulation is happening, and then how whether we can do this. So for this purpose, one need to do a cell type specific omics, whether it is a proteomics, transcriptomics or metabolomics. For that purpose, we need to require different kinds of promoters which are all very specific to very specific cell types. For example, here I can show you a root cap specific marker as in green channel, and then a propionamided red and green channel, which is specifically marking in that particular root tip itself or root cap itself. Now what I can do is, I go to next one. If I go to a kind of a generating around 50 to 60,000 seedlings, because mind you that the root cap is 100 to 200 cells max, and then if I want to do replications and others, I need to collect at least for replication 15,000 to 20,000 seedlings. From that many seedlings, I have to isolate protoplast. Then I go to the pack sorting, and then in the pack sorting, I can sort green cells and then non-green cells. The green cells are the root cap cells, non-green cells are the rest of the cell types. Then we came to know that when under salt stress, how a root cap is signaling, and then how the root cap is perceiving it, how the root cap signaling mechanism is happening. So this one slide is a work of 5 years PhD from a student, where now we came to know that under salt stress, later on also cadmium stress, what are all the molecular players that are playing a role in this particular kind of. So now what is happening is, most of the time we are looking into more cellular level, going into further subtractionation, then what is the use of that? Because we always believe seeing is believing, and then we also thought that how we can utilize it for the translational purposes. So for that direction, we were also asking that question. And when I grow these transgenic barley plants or in the maize plants at Brassica, I noticed something. We are also always curious about it, like senescence we know, the aging of the plants we know that, and then we have reproductive senescence is also there and developmental senescence is also there. But whether the same applicable for the roots, when the roots are under stress, whether the stress associated senescence will be happen or programs that happens, or if there is no stress also, whether the roots are get aged, when the plant is growing towards it, whether they get aged. When I see in our initial direction, when I increase the root biomass, normally root aging is, we can see that cell death by browning of the root tissues. Now you can see here the transgenic plants where the cytokinin is deficient, more number of plants or more number of roots, new lateral roots are coming, so the browning is reduced and the white coloration can be seen. So we asked this particular question, and then when we look at it, unlike the above ground senescence, where a particular events and then the players that are looking at it, how the macromoleculars after senescence leaves towards going into the young tissues, young leaves or reproductive organs, reproductive things, the root system is not there. But however, you remember that majority of most of the zinc place in the entire plant organism is the root only. Now the root possesses abundant amount of carbon. That entire carbon, what is happening to that carbon? Because plant invests so much into that, and then now when the roots are get aged and they got died, where they are going? Or they are going to soil back, or they are going to transport it? If yes, how they are going to do? So for this purpose, what we did is we continuously looking into different developmental stages, stage by stage, and then we use hydroponics method, harvest the material, the young tissue, little bit old tissue, and then aged tissue, and did the metabolomics. And then we identified there is a stark differences between metabolite profiling of those roots that are already kind of delayed in their aging, and then those roots that are already aged along with the developmental. So these metabolites, right now we are trying to find it out, the genes and the proteins that are responsible behind these metabolites and others, what are the implication of these ones. For example, when we want to increase the healthiness of the plant, so that because healthy roots means healthy plants, then how we can utilize this one. The next thing is, like I said, that seeing is believing it, and then we want to study the root pathogen system and then host pathogen interaction from the root side. Most of the time, when we see pathologic symptoms from the above ground, we see spots, we see wilting, or we see kind of necrosis leaves and others. By the time we came to know this one, already a lot of load of this bacteria, fungal and everything is already entered into the system. So we want to understand particularly the soil-borne pathogens, how they enter into it. Then the next question is whether we can able to see it. And with the help of, if you see over the video, small video over there, the green color is moving around. That's a microfluidic setup. What is microfluidic setup is using a normal PDMS media, and then at the microscope level, one can make a 3D printed ones. There itself, we can put it over Arabidopsis or something. Then it's a kind of a normal slide. What you can see over there, it's a normal slide. Now you can see now the root hair, how I can track it. The root hairs are also important agronomical parameters in terms of water and then biotic interactions, their quantifications. Then at the same time, I can understand the growth behavior. Now I inject normally this one and also with a pathogen or a beneficial bacteria, a PCBR. Then I will understand how the plant is responding towards it. Now this is bit of low resolution. Now next level, I go to a kind of a high-level confocal imaging screen where I can even go for cell type specific experiment. So by this way, then I came across a particular gene from this kind of a screen, which is upon infection to the Ralstonia solanacearum causing bacterial wilt and Fusarium oxysporum causing fungal wilt. These two pathogens, they try to down-regulate a particular gene in Arabidopsis. So you can see the expression normally under control conditions. The root cap is marked with the green color, GFP fluorescence. Upon infection, after 5 days after infection, you can see that gradually that the expression of this particular gene is missing, indicating that after infection, either it is a plant mediated or it is a bacteria mediated or fungi mediated, this particular gene is going to be downregulated. So then we asked that particular question, so what is the meaning of that particular one? Then we created a loss of function, gain of function, mutant cell Arabidopsis, and then we treated them with the Ralstonia bacterial wilt. And we see that whenever we increase this particular protein expression, then the plant becoming more susceptible. When this particular protein is removed, that is loss of function, then the plant becoming more tolerant than the control plant. So how we can see that one? The next, on the right side of your on the right side of your slide, you can see this is a bright field pictures where the red color is coming from the M-cherry tagged Ralstonia. So the bacteria itself is tagged with a protein. Now when it is a bacteria tagged with the fluorescent protein, the movement from the control to each 12 hours, 48 hours, 72 hours, we put out a live imaging thing. Then we will get to know how the bacteria is going layer by layer until it reaches its final destination, the vascular system. So now we can see in the wild type, after 5 days of the post-infection, entire red color is there in vascular system, whereas in the loss of function it is not there. It's not the case. Whereas the gain of function, you can see much more bacteria in all cell files, including the vascular system, indicating that bacteria trying to activate this particular gene or downregulate it by plant, and then plant trying to downregulate this one as a kind of a gene. Now I understand this one from the basic research. This can be as a kind of a useful target. Then whether I can do that in a crop plants. So what we did recently is then the same knowledge we take it to the tomato, another dicot plant, which is both bacterial wilt and fungal wilt, is causing a lot of damage. We do have some kind of genetic resources that are resistant towards it, and then we do also try to get those ones and then studying it. What we did is, what are all these genes? Whether from the, and then we use a pangenomics approach. From the whole genome triplication onwards, if these are all the genes that are causing the susceptibility, whether the plant is trying to lose it or during the evolution, or if it is necessary, they are trying to keep it. And then we are trying to look at it, if they are still there, even after this one, from the wild relatives of the tomatoes, Cercifami and then Pimpinelli, all these ones we look into it. And then we came across some candidate genes, which are all very specifically expressed in fruits, in the roots, in like that. We kind of validated them using susceptible and resistant genotypes that are available in tomato. And then we also did Wix-mediated silencing. Again, we prove that when we down-regulating this particular one, tomato plant is going to be tolerant to this particular pathogen. So we are now having candidate genes. One is for Fusarium, another one is for Ralstonia, another one is for Polytotrine. So for these ones now we are trying to do very specifically genome editing so that we are trying to get it. We create a loss of function, we are trying to get it out, whether we can make a susceptible tomato variety can be more tolerant towards this. So while we are doing this one, next before slide there is one slide. So while we are doing this one, we all know that, many of you also know that who are working with tomato, I think less number of people here work with tomato, but normally for fungal wilt, biological control is Trichoderma viridis. So people use the Trichoderma viridis as a biological agent, and then we are interested in a similar kind of a setup. We were interested, we put a 3D printing labels, and then we use Fusarium oxysporum, Thomas lycospersae, and then we use Trichoderma viridis and plant, put a susceptible plant, and then we try to collect the metabolites from each compartments and others, and then try to understand how, when Trichoderma viridis is present, then how the plant is becoming tolerant, and then when it is absent, why it is tolerant, and then if it is there, and then what kind of metabolites that are responsible for that. So this is what is again possible, and then again we can created this kind of compartments and then collect the exudates, collect the metabolites from it very specific. And then these processes can be done within the laboratory setup, and then using both susceptible and tolerant varieties, and then we also did metabolomics. Now I said that carbon allocation is one of the major thing, and then I pointed out that when we increase the zinc, root zinc as a kind of a thing, we got a lot of benefits. Then what will happen when we increase the reproductive zinc? Another major thing is after vegetative stage, roots are the major zincs. After reproductive phase, then the reproductive organs are the major zincs. What will happen when we increase the reproductive zinc strength? Whether it can be, how the allocation will be there. I always give a typical example. Many of us know that inflorescence is so much, then the fertilization is happening, but still after, particularly in case of fruits and other crops, you can see that they will be aborted. And then that abortion can happen sometimes, it will be 50%, sometimes it is 30%. Flower to fruit ratio is becoming never be 100 in many of the crops. Then the question is why? So what is happening? Whether plant is able to provide sufficient resources towards this particular zinc? If it is there, what is the mechanism behind this one? So we try to understand with the classical approaches where phytohormone, cytokinin, and then the genes that are responsible for controlling the sugar signaling during this carbon partitioning about this one. We came across a specific set of genes and others which we are editing now. We are increasing the both vegetative zinc and reproductive zinc simultaneously by genome edited lines, and then we try to ask that question when zinc or a vegetative source is not limited, then the reproductive zinc strength will increase. If yes, so how it will be useful? If not, what is the factors that are regulating it? We already have genome edited lines for this where vegetative zinc, as you can see, branching pattern and then vegetative biomass so much increase. We also quantified the total number of flowers, inflorescences, everything is increased in genome edited lines. Now we are quantifying it whether this flower to fruit ratio is increased or not, and then later on we are coming back to, I will just slowly come back to the cereals and then slowly to the finger millet. So coming back to the rice, with the help of Agriculture University here, from where I came from, with the help of my colleagues in the breeding and molecular biotechnology department, we did a lot of work on terminal droughtlessness, mutational breeding we did it. We also identified a particular variety right now this is under IVT, and which is in the MT content background. And we also studied trying to look for the blast disease resistance. And I think many of you know already, our DDG sir is the one person in India who worked on blast disease for the last 25 years. And then most of the genes of PI54, that is what we are now, all the breeders are using in across the plant species to create a blast disease tolerance is the same gene which he identified. Then another DSR, right? So first is that I said that we are using reproductive drought stress, we are identifying the variety and others, we try to understand what it is, the mechanism behind this terminal drought stress. And for the blast, like I said that this time instead of going from the lab to field, I want to come back from the field to lab. So how I started this one is, I did first meta-transcriptomic analysis that are already publicly available, and then trying to fish out some susceptibility genes and others. Then 3 years continuously with the help of several colleagues, whenever I got a phone call that in Martero Rice Research Station now blast is so much spread, I go there, collect the samples. Nellore, I went there, collect the sample. In DRR, which I always remember as DRR, IARR, again I collect the samples. Like that, we go there, take the permission and only collect the leaf samples and then store it. Like repeatedly we do this one with the help of scientists over there. And then from those samples over 3 years, 3 different seasons, 3 years, and then also greenhouse condition sense. Now all the list of the genes that we came across from the meta-transcriptomics, we did a lot of QPCs, I think maybe 200, 300 and others. Then we ended up having only 3 or 4 or 5 genes, candidate genes, which are performing the way that we are looking for it. For example, in a susceptible genotypes, this particular gene is highly upregulating. In a tolerant genotype, it is not. Other way around, in susceptible genotype, it is completely downregulated, intolerant not. We always use BPT 520 for the susceptible and TETAP, which is where the resistance was cells are identified that is as a tolerant gene. And we have 3 candidate genes now, which we consider as 2 of them are susceptibility gene, S genes, one is an R gene, which we are working now for making genome editing. While we are working on this rice blast, then we thought the moment we came over here, and then one of the things that we tried along with our colleague partners and others, we thought like, okay, why not work on millets? And then at that time, what is a major problem in millets? And people told me that it is pearl millet blast and then also a finger millet blast. And whatever is available at that time, I went to Dr. Hemant, who is a epidemiology leader at that time, and Dr. Hemalata, who was a pathologist over there. And then they are screening germplasm, where they are utilizing PR708 as a susceptible check, and then at that time GPU67 as a kind of resistance. We take these kind of samples and say that, okay, what is happening over here? This is the same genes. Then we did a RNA-seq between the susceptible and resistant genotypes. We try to understand what are all the genes in finger millet and that are regulating under leaf blast and neck blast, these different samples. And then we compare them. If now finger millet has a set of genes, rice has a set of genes, and then somebody published in wheat, they have a set of genes. Then we are looking for whether we can able to find out a common genes among three of them. Now you remember that the pathogen that's causing finger millet blast, the strain is bit different. Sometimes it is not able to cause the disease in rice, vice versa too. Then the wheat, vice versa too. In spite of that, we thought that whether the mechanism behind these three plants, whether we can able to find any particular kind of a conjured genes. Then we identified some of them. Then we also look from the pathogen side. If any of the effector has ability to interact with the candidate genes that we are having it. And then we did an in silico analysis and tried to see that whether they can able to really interact with it. So this can be a kind of a good candidate for us in order to do this particular one. So the another root related research that we are doing is, and then everyone nowadays in the rice field, people want to have DSR, and I don't need to explain what is the importance of DSR in present climate change conditions. So what we did is in DSR is, it is very well known from Giri, there is a paper. They say that early root vigor traits along with early seedling vigor traits is an important criteria for a genotype to be established under DSR conditions. Since we work on roots and others, so we thought like, okay, why not again come back from the field to the lab. So this time what we did is, we take 200 genotypes. These 200 genotypes are not from the 3K panel. These 200 genotypes are different. These are all southern part of India, very well characterized. Some of them are directly in high yielding varieties and others. Then we choose three different conditions: laboratory conditions, wet DSR conditions, dry DSR conditions, in three different time points: 7 days, 14 days, 21 days. And then we collected 15 different kinds of traits: root length, shoot length, root biomass. Like that, we did all the things. Then we did a GWAS, we did a GBS, we did a GWAS. Then we identified traits, and then we look for the diversity among them. And then we kind of find them that both in wet and dry DSR, how they are behaving. This work is done with the help of Indian Institute of Rice Research. They are only in that field and we use it. Then, again interestingly here, again we want to go for MTAs that are common across all these three conditions. In the lab, or wet DSR or dry DSR, or only wet DSR and dry DSR, a particular trait. And then if that is a common MTA or same location they are coming out, and then we want to ask what is that particular gene. So interestingly, I can show you over here because interested in the root I am. Now it is in the root dry biomass, both under wet DSR and dry DSR, exactly on a similar chromosome, same location, we find an MTA, indicating that even you change the conditions in different year, different period, then we came across an MTA exactly in the same location. That genes underlying that particular MTA might be important for that. And then right now we are working on genome editing, prioritization of the candidate genes, validation of them, and then going for genome editing. So this is my work. Since many of you come from across our country and then several of you don't know about IISER Tirupati, I just used 2 minutes now to talk about IISER Tirupati. This is our brand new campus, a greenfield campus, around 250 acres. 35 kilometers away from Tirupati on the way towards the Kalahasti. And this is one of the 7 IISERs we are having it. And then we are having we are very much interested in agriculture research, and then we are at the moment 4 people working on agriculture research, and then you already heard me a lot, and then our director is working on pheromones, and he has also different kinds of biochemistry related tools for applied aspects of agriculture. I have another colleague, Dr. Annapurna. She is working on priming stress and heat and combined heat and droughts. And Sarup Rai Chaudhary, he works on more nodulation and desiccation tolerance using Sellaginella as a model for desiccation, nodulation, chickpea and groundnut as a model plants. He is working. And Dr. Annapurna works as a priming as a agent in order to alleviate the heat stress, and she also works on combined drought and heat responses using priming as an indication. So we are very much interested in basic research, but having application oriented, and then we really want to collaborate with people like you who are having enormous amount of data, who are having the real scenario under field conditions. So we want to learn from you, take the problem from you, from your observations, from your experiences, and then work it out at the laboratory conditions, and then want to work together. So our location is such a way that we are taking technological help from IIT Tirupati, and then sometimes we take the agriculture from all the 4 agriculture universities. We have to do some collaborations, but minute ones, and then we get a lot of resources from remaining ICES, and then some of the companies we are already incubating in our campuses, which are all working in the different areas of agriculture allied sectors. So my humble request for all of you is please visit us and then collaborate us, give us a chance to work with you and then to learn from you. Thank you.
Thank you very much, Dr. Reddy, for excellent talk. Really enjoyed it, and I'm sure that my colleague in this hall, they might have learned so many things from your talk. Now we can open it for discussion maybe for 5 minutes. So any question from the audience? Yeah. Not audible.
Yeah, thank you, sir, for an interesting talk. So I had 2 questions. One was you worked on susceptibility genes while trying to deal with the blast.
Yes.
Why did you choose susceptibility genes? Why not the resistant one? Is it for the ease of genome editing?
Not only that, ma'am. For example, if you take about it, susceptibility genes are the hotspots for the pathogen to work with, because the susceptibility gene sometimes often is a key gene for the plant. Plant cannot afford to lose that. Take an example of bacterial leaf blight sweet gene. Sweet gene transporters are necessary for the plant to survive. Now, tail factors are very specifically regulated the sweet gene ones. Now, I cannot remove completely sweet gene because plant will affect. And then pathogen choose these kind of genes such a way that plant cannot avoid completely down-regulate this entire gene. Now, the pathogen intellectually, I would say, try to choose this kind of gene so that plant cannot make any defense either to degrade that particular protein. If it degrades its protein, its own growth and development will. So when we identified this kind of thing, then it is easy. I think we can contribute more. Whereas our genes are like a bodyguards. They are do very direct defense. Whereas susceptibility genes are kind of a Trojan horse. These are like, they are inside, we don't know. They are the ones who are giving it. And then how much our gene thing? There are sometimes very strong our genes. But sometimes these hidden ones, which are all behind it, they do a lot of damage. And then, like you rightly pointed out, that it is also kind of, for example, I can go now the genome editing and then get rid of the regulatory of the transgene and other things. That is also one of.
Sir, another one is?
Yeah, go ahead.
Okay, tomato, you mentioned about genome edited crops for enhancing the reproductive sync.
Yes.
Is there any particular genes that you targeted? There was nothing mentioned.
Yes, there I was targeting about the well-known cytokinin degrading enzyme CKX genes. And then we all know that CKX increases the grain number. Actually, that comes from my own lab where I started. We have also patented long ago on that. And then now we know that in IAR, Dr. Satyendra created this one, and then Dr. M.K. Reddy from ICG, we did MTU 1010 background, Sajendra did in PPT team. It's everywhere, wherever people are doing. Now we did in Marley right now, which is under field trial in Switzerland. Everywhere when you target CKX, grain number increases. But nobody shows that whether the fruit number is also does. And then it is not there. And then we are trying to see that whether there is a way for it, and then can also see it.
Thank you.
Thank you. Dr. Pradhan.
Very good your study, good presentation also. My curiosity is that when you are phenotyping for root parameters, say for example a panel you took 200 and you did the marker trait association. So in that case, what is my suggestion is that there is a chance of spurious association. 200 phenotyping is will take a lot of time. All the parameter replication, it is very much difficult. So in order to go for very precision way, can we not take the seedling parameter instead of plant parameters? Suppose you can simplify using the seedlings, maybe just after germinating, measure the root length and the gene itself. So how you will be 200 root architecture you will be doing phenotyping for that? Root length, root volume, root mass, it's spurious association. So that is, whether it is applicable to the seedlings or not, that is my
Okay, so why I did these 3 different conditions is also the same thing. Normally people use the germination paper tables and others people do that. I also did initially with the 200 genotypes of this one. However, as my experience with the roots and the root genome in the last 10 years, I know that when I grow the roots from the very well nutritional MS agar medium or very good soil, and then how we are giving it, the behavior is different than when I directly growing in a field. So now I can came across a particular biomass thing or a kind of a dried thing. Maybe when in the field, it may not be the truth. And why it is the friction that normally is necessary while the root is growing towards it. And then the way the compaction, soil compaction, also matters a lot. A lot of microhormone signaling is happening between to understand how the soil porosity and compaction, how it is determining it. So the same genotype, which is normally we thought like, oh, it is going good, when it is going to a kind of a conditions over there, then it is not performing well. So the whole motto that I want to do across 3 different conditions and try to find out the common needs, to try to avoid this afterwards. I identified an MPA, then I identified a genotype. I know that it is a lot of laborious, the person who are working on that, and then we employed a lot of laborers in agriculture. This is not possible in my institute. It is because of Indian Institute of Rice Research it is possible. It is because they have the resources and others, and then there only we are able to do it. Normally in our conditions, even though we want to try to field, we do at the laboratory level. But the laboratory level has its own disadvantage.
So what was the variance for this MTA for markers? How much you got next week?
How many?
Your variance for markers variance in case of MTA was 30%, 20%, 50%.
Phenotypic variation.
Phenotypic
variation. We were right now at the 20 to 30%. It's in between.
Anybody? Yes.
Thank you, Ishwar. It was excellent presentation.
Thank you, sir.
And because you are working in finger millet now, and as an institute, we are also working on finger millet and other millets like foxtail and all. One of our main objective is, unlike in millet and so on, we don't have very heterosis breeding. So is it possible for you to edit finger millet lines to have a mesh sterility system so that it helps us for having a hybrid? So can we work together in that aspect to induce mesh sterility through genetic genome editing?
Okay, I can tell in front of everyone. This is one of the project we write it to our ICRISAT colleagues to the DVT, and which is now in the cold storage, that way we want to increase this kind of thing. it is not there. So at moral level, I cannot propose the same project because it is still under in their ranks, right? Then other kind of things. So if I can withdraw that one, we are definitely want to come.
Anyway, but there is a proposal.
Yeah, there is a
Very good presentation, excellent talk. It has opened up new avenues for us to think in a different direction. In Pearl Millet, we have this critical A1 zone, where we have this heat stress, temperature stress, water stress, everything is there. And we want to come up with genotypes which can tolerate and come up with good yield. And when we were trying to study the mechanisms, people were not able to come up with real good science in that basic work. In front of everyone, I would like to request you to have a collaboration with Indian Institute of Millet Research, and we can work together to identify the mechanism for this heat stress, seedling stress tolerance. And also in one point you mentioned that the plants produce this reproductive sink. In Pearl Millet again, we see that a large amount of pollen is produced, a huge amount of pollen. That much quantity of pollen is not required for the plant. And yes, so there is something in the plant which is producing it in spite of it being required in very little quantity. We need to understand that, and some basic studies in this direction will be really good and will open up new avenues for further research in millets. So we would definitely like to have a collaboration with you.
Any other question? Maybe one from. Okay, if there is no other question, then I just have one clarification. Although 2 questions that lady asked, I wrote all those questions there, but I already got the answer from those questions. What I would like to ask you, in tomato and rice, the genes for susceptibility which you are targeting, are they same or different?
Different.
Because if we see the sweet gene in rice, which is its orthologs are present now in many crops. Similarly, the gene which you have identified, do you expect their orthologs in other crops?
We are expecting, that's why we thought in the last for the first question, the genes that we are working on tomato for bacterial and fusarium wilt are completely different than the blast in the rice and finger millet. So the whole idea that we want to expand from the, because in the rice, because people like we have vast knowledge of blast is there and then other genes. But the similar kind of science is not there behind finger millet, millet. But even though we have a wealth of genetic resources available, several of my own colleagues are also who are in ICL system screen a lot of blast diseases. But now using this well, and then the sign that we came across from the metatranscriptomics, we would like to see whether these are all conserved or whether different. And then from pathogen side also we want to understand why a particular strain is only infect finger millet or bell millet but not rice, or why the rice agricultural strain it is not there. What is this strain diversity? From there, any effect or are different? What is those effects? Those is also
okay. And in other scenario, if you see in almost all crops, we studied around 20-25 crops, genomes, for the presence of defense response and disease resistance genes. And in all those crops, these R genes are present in clusters and in multiple in number. But we never looked at susceptibility genes. Are these also present in clusters? Or
yes.
You have to.
Yeah, we from the tomato we did this pan-genome analysis from their wild relatives, from their ancestors. This one is we want to understand whether these group of genes they are also clusters or sometimes they are tandem repeats.
Okay.
They are duplicated.
Yeah.
And then they are
or sometimes pseudogenes.
Yeah, and then we thought like, okay, why it is happening? Why they are retained? Why they are duplicated? And then from the wild relatives to the cultivated one, sometimes we lost them. And then the wild relative, if it is tolerant, now we lost it in overbreeding, then we have already candidate. That is how
Okay, thank you, Dr. Reddy, for excellent talk, and I'm sure that many of my colleagues and friends from this particular group of millets, they will definitely approach you. And you have not shown your email ID here, I think.
No, sir.
So that they can contact you, or you can just Google ISA's Tirupati's website, and then you can send your queries to him, or you can have collaboration with his group or all those three scientists or 4 scientists working in this area, particularly in plant biology. So thank you very much, and best of luck for your work.
We request the chair and co-chair of the session to kindly felicitate our guest, Dr. Ishwar Ramiredi. Thank you, sir. Thank you, madam. We shall begin the plenary session shortly.
That is well proven. We can do that. So the angle is genetically controlled? Yes. Genetically controlled, for example, in rice, there is no one is there, that is only controlling, and CKS2 is there, which is controlling the adventitious growth area. So instead of growing like this, it will be like this. And then the photo that I showed of the senescence, you can see actually that was done, the experiment was done for root hanging. I have that picture where it's like roots are going naturally from the side.
We are beginning the plenary session of the combined AGM, AICRP Pearl Millets, Sorghum and Small Millets 2024, VIC proceedings and technical session-wise recommendations. We request the dignitaries to kindly occupy their seats on the dais. We request the chairman, DDG Crop Science ICR New Delhi, Dr. T.R. Sharma, and the co-chairman of the session, ADG FFC ICR Dr. S.K. Pradhan, to kindly occupy the seats on the dais. We also request Director IAMR and Project Coordinator Pearl Millet Dr. C. Tara Satyavati to come and occupy the seat on the dais. We also invite Dr. R. Madhusudana, Project Coordinator, Sorghum and Small Millets, to occupy the seats on the dais. And Dr. S.S. Mane, member of PAMC, sir, kindly come forward and occupy the seat on the dais. Shall also request Dr. V. Sumadi, ADR, RARS Tirupati, to kindly occupy the seat on the dais. Before we hand over the session to the chairman, we request Dr. J. Stanley. I shall request Chairman Dr. T.R. Sharma sir to kindly begin the proceedings.
Good afternoon, colleagues. Now we are at the fag end of our 2 days annual workshop of millets, and I'm sure that you might have enjoyed during these 2 days all the discussions and presentations. I have my co-chair Dr. S.K. Pradhan, ADG FFC, and we do have Director, Indian Institute of Millet Research and coordinators with us. And as per the listed program, now I will request Dr. Stanley for making the presentation on main recommendations of all the sessions together. Dr. Stanley.
Respected Chair of this session, Dr. T.R. Sharma, Deputy Director General, Crop Science, the Co-Chair, Dr. S.K. Pradhan, Assistant Director General, FFC, and all other members of the dais. I am here to present the recommendations which were made in each session. Unlike other inaugural session, in this inaugural session itself we had many recommendations, and very good and relevant recommendations are there. So I am reading one by one. The first one is new male sterility system for hybrid development in pearl millet is to be identified. Germ blossom lines to be screened for low rancidity, and use of gene editing tools for lipoxygenase and other related genes to enhance shelf life in millets. Explore the possibility of utilization of apomixis for development of true breeding lines and fixation of heterosis. Gene pyramiding or staking with major gene governing diseases or insect resistance, and development of multiple resistant lines. Development of farmers-friendly post-harvest technologies to be developed. Development of region-specific production profiles to target production regions are to be identified. Productivity to be increased in all the small millets to make millet cultivation profitable to the farmers. Use of advanced genomic and phenomic approaches to target nutritional traits. These are the recommendations of the inaugural session. We had the second session, a session on plant breeding and genetic resources, which were chaired by Dr. T.R. Sharma, DDGCS, ICR, and co-chaired by Dr. S.K. Pradhan, ADG, FFC, FICR. The recommendations are as follows. In pearl millet, considering very few entries promoted in various trials, there is a need to select diverse parental lines for hybridization and evaluation across the different locations. In forage sorghum, the strong collaboration with institutes like IGFRI, Jhansi for single and multi-cut sorghum trials is essential. Strong industrial collaboration is essential for standard commercial evaluation of high ethanol lines in sorghum. In small millets, existing germ blossom are to be evaluated for core and mini core across the different locations. Major attention should be given to small millets for large-scale cultivation, collection, evaluation, and conservation of germ blossom lines. ICAR, IAMR, and ICR NPBGR should collaborate to import diverse germ blossom lines of small millets specifically from different countries. The next session is on crop production, which was chaired by Dr. Lakshmikant, Director ICR VPKS Almora, and co-chaired by Dr. V. Chandrika, Professor and Head, Department of Agronomy, SVAC Tirupati. The recommendations are as follows. Crop geometry experiments needed to be conducted for small millets. Cost effectiveness of nano urea application and hydrogels are to be assessed. Farm machinery to control weeds in small millets need to be explored, as weeding is cumbersome in small millet cultivation. Early sowing with lesser plant densities along with suitable varieties are needed to be identified to address the climate change effects in sorghum. Use of locally available agricultural residues as mulch to minimize evaporation and conserve soil moisture are to be explored. The next session is on crop protection, that is specifically plant pathology, which was chaired by Dr. S.S. Mane, Director Research, PDKV Akola, and co-chaired by Dr. Reddy Kumar, Principal Scientist, Plant Pathology. QTLs identified for grain mold resistance by different workers may be studied for pyramiding in elite cultivars. Compatibility of biocontrol agents used for the management of blast in pearl millet is to be studied. And the next session is on crop protection entomology, which was chaired by Dr. Prabhakar, ex-PC in millets, and co-chaired by Dr. Murali Krishna, University Head Entomology. The recommendations are as follows. Hotspots for various insect pests are to be identified for pearl millet insect pest screening trials. Resistant and susceptible checks should be identified to be used for screening trials for insect pests of pearl millet. Studies on biochemical aspects of resistant genotypes needed to be carried out in sorghum. Parbani can be included as the center for the newly formulated mid screening trials. Apart from taxonomic studies, some management trials are to be formulated for shoot fly in all the small millets. Standard, resistant and susceptible checks should be identified in each small millet crop and to be evaluated. Next session is on outreach activities, seed production, IPR and ICR ICRISAT trials. The session was chaired by Dr. Sanjay Kumar, the Director of ICR Indian Institute of Seed Science MAU, and co-chaired by Dr. T. Lakshmi, Head of Agriculture Extension, SVAC Tirupati. The recommendations are as follows. Increase resources for targeted extension services to support sorghum and small millet farmers, focusing on technical assistance and new varietal promotion. Any issues related to operation of Sati portal may be brought to the notice of IASS MAU for resolution for smooth conduct of breeder seed production against DFW intent. The old cultivars in the seed chain may be replaced with the recently released cultivars. Thank you.
Thank you, Dr. Stanley. That's how probably in all the AICRP we expect that very brief actionable points should come out from all the sessions. And I'm really happy to note that from all the sessions very good points were emerged. And next year we should follow these points in terms of action taken. So now I will invite Dr. C. Tarasatyavati, Director, Indian Institute of Millet Research, for VIC proceeding on pearl millet.
Very good afternoon to you all. Respected Chairman and Co-Chair, yesterday we had the Varietal Information Committee meeting held in the evening on 27th of June, wherein two proposals of pearl millet were considered. MH2626, that is MP7214, where it is proposed for Zone A, and this has been identified and recommended for release. The other proposal, MH2631, that is PB1939, again which has been proposed for Zone A under late condition, has also been considered for release. That's all.
Thank you, Madam. Thank you very much. Dr. Madhusudan for presentation of millets.
Respected Chair and Co-Chair and Director and my colleagues, so I will be presenting the proceedings of the sorghum VIC. So in total we had 9 proposals considered with the VAC committee, and following is the recommendations from them. So the first one is SPH 1974 proposed by US Dharwad for the states of Karnataka, Tamil Nadu and Rajasthan. It is recommended. The next is SPV 2871, a variety from IIM Hyderabad, which is proposed for Telangana and Gujarat. It is not considered, not recommended. Third is another Kharif sorghum dual purpose variety, that is SPV 2773 from Dharwad Center for the states of Karnataka, Telangana, Madhya Pradesh, Gujarat and Rajasthan. It is recommended. Coming to Rabi sorghum varieties, that is SPV 2918, that is from Solapur Center of IIMR Hyderabad for the states of Karnataka and Maharashtra, is not recommended. Again, one more variety, that is Rabi sorghum variety, that is 2927 from US Dharwad for the states of Karnataka and Maharashtra. It is not recommended. 2 varieties were there for sorghum, forage sorghum, that is both for single cut forage sorghum varieties. One from Hisar, that is SPV 2881. It is recommended. Another single cut variety, that is SPV 2884 from ICAR-IMR for the states of Maharashtra, Tamil Nadu and Karnataka, is again recommended. Coming to seed sorghum category, so we had only one sweet sorghum variety, that is SPV 2890 proposed from IIMR Hyderabad for the states of Tamil Nadu, Andhra Pradesh, Telangana, Karnataka, Maharashtra, Gujarat, Madhya Pradesh, Uttar Pradesh and Punjab. It is recommended. So one more special variety sorghum was there, that is yellow sorghum variety SPV 2906, that is proposed from Akola, PDKV Akola for the states of Maharashtra, Karnataka, Telangana and Gujarat. It is recommended. Besides that, sir, just I would like to submit, there were other 4 proposals from Palem, 2 from Vijayapura and 1 from Rahuri. Palem was a yellow sorghum variety. So these 4 proposals are actually we scrutinized at PC unit level in morning was the PID, and we took based on the merits and demerits of that we considered, and in the data we went through the states all 3 years and we took a decision that not to put in front of years. So these varieties, that is SPV 2907 from Palem, 2935 from Vijayapur, 2757 from Vijayapur, and SPV 20, these 3 were not recommended. And the SPV 2751, actually we received this proposal only 2 days back. So we got we submitted the statement, but this Dr. DDC said that instructed that it may be considered next year. They have to put forward this proposal possibly next year. So this is the summary, sir.
Okay, thank you very much, Dr. Madhusudhan. Congratulations to all the workers associated with all these varieties. And small millets are still left.
So sorry. Coming to the small millets, sir, there were 7 proposals for there. So figure millet variety is FME 1209, that is from Almora, that is recommended. And foxtail millet, that is FXV 647 proposed from Solapur, it is recommended. Again, one more foxtail variety from US Bangalore, that is FXV 652, it is recommended. Little millet variety, that is LMG 539, that is from Andhra Vizianagaram for the states of Madhya Pradesh and Chhattisgarh, again it is recommended. One more Proso millet variety, that is PME 472 from Dharwad for the states of Karnataka, Tamil Nadu and Pondicherry. This is not recommended, it is not recommended. Same center, that is US Dharwad, has proposed one more Proso millet variety, that is PME 475 for the states of Andhra Pradesh, Karnataka, Tamil Nadu and Pondicherry. It is recommended. And brown top millet, that is BTV 31 from US Dharwad for the states of Andhra Pradesh, Tamil Nadu and Maharashtra. It is recommended. So congratulations to all the sorghum and small millets leaders and their team for having a variety recommended to VAC. Thank you very much, sir.
Okay. I think we should give clapping to all the workers associated with these varieties. Thank you very much, Dr. Madhusudhan. We will move to now next item, which is remarks of PMC, and we have with us Dr. S.S. Mane, member PMC, for his brief comments.
Good afternoon to all of you. The chairman of session, Dr. T.R. Sharma, DDT Education, DDG Crop Science. Co-chair is Dr. S.K. Pradhan. Director IC ARIMR Tara Satyavati, Dr. Madhusudan, all the dignitaries present in the hall, and all the delegates and dear members. We have two meetings. One is held at Bangalore, so I think Hyderabad, and another meeting was held at online. In the both the meetings, they have this year, coming year, they have formulated very good projects, and hopefully they will be getting good result. And most of the thing, as far as these pearl millets and pearl millets, small millets, and these other millets are concerned, most of the problems will be taken care of. But sir, being a plant pathologist, I like to put few things before you, as you yesterday said that there should be the identification of disease. This is the most important thing, because every year when we are analyzing the chickpea data, we find that some of the my genotypes, they are showing susceptibility at a Hissar wild chick plot, but the same genotype is showing the resistance at Akola and Ecrisat wild chick plot. So that means that there are definitely the variability in the pathogen. There is occurrence of the races, and accordingly, if we deploy the gene deployment or gene pyramiding is done, then definitely whatever the losses which has happened because of the disease, that is around 20 to 30%, we can definitely reduce it, and And with these few words, I thanks for giving opportunity to present on this workshop here. Thank you very much.
Thank you very much, Dr. Vane, for your comments and also your input during all the sessions to our experts in millets. Now I will request co-chair Dr. S.K. Pradhan for his brief comments.
Very good afternoon to all. Honorable Chairman of this session, closing session, Dr. Sharmaji, Deputy Director General Crop Science, ICAR. With us, Director IMR, Dr. Tara Satyavati, then our project coordinator, Dr. Madhusudana, with us, Dr. Sumati, Associate Dean, and then our PhD member, Dr. Made, also Almoda Director, BPKS Almoda Director here is Dr. Lakshmikant, former PC of Small Millets, and also very important partners of this collaborating center, particularly host institution, local organizing committee chairmen, members, and dear participants from various parts of the country, and then press and media. Really, this is a very happy moment for us after a long marathon. Actually, not 2 days, really it is a 7 days effectively. We come to conclusion to our last phase. That is 5 days for pre-group meeting, totally one-to-one, for 2 days for millets and 3 days for sorghum and small millets. So again, physically we just we are here to discuss, to confirm our program and results. So we are here for 2 days. So in total, it is a very detailed discussion, thorough discussion, 7 days program. So I am very happy that here this is a very successful one. Here, starting from the evaluation of the center, we find a lot of centers actually really doing well. They are progressing well. the experiment and do the basic study, so that in future your information can be again put into the action, and result is very encouraging compared to the previous center. I can say previous year. This year the progress is happy moments for us. We have also started some of the places mapping of the genes, particularly for those which are not reported. It's a very planned way. Also, we have started genomics selection in case of few centers. So I hope all the centers, they should think for being involved in those, and now we should not think of a single gene, QTL, putting in the breeding program and will take 5 years. Time has gone. We have only, as I told you, we have only 15 years with us. Now 23, 24, we are in 25. So by 2047, another 15 years. So by that we have to get the target of our about 40 million tons. It's a challenge for us, but it is, if you, the way we are planning, if you will execute, that is not difficult. We are targeting about 15 million hectares. If average productivity we will be targeting 2.5 tons, which is already achieved in case of corn, millet and sorghum. So average, if we will be thinking also, we are achieving our goal, our target. So that is not a challenge. Of course, I cannot say a challenge. So just improvement of few traits simultaneously you can think, and you're just pre-breeding and including in the breeding program diversity searching and all those things, you will be able to also do this. Also the main things like how it will reach to the common people, I was telling also. It's now not in the common people's plate. It is only in the urban mass. Its marketing is something different. It's, some high cost type thing. So how to reduce the cost? Unless we achieve or we go our targeted production, this rate will not come down. Again, how it will come to the PDS? This cheaper way. If we can do higher production our target, if you think, then we can achieve our goal. So at the end, I take home message, say you that this is not a challenge to us. It is a achievable, easy target, and you only think executing the experiment very precisely without committing much error. So the time and execution of experiment should be proper, so that the monitoring team will be able to appreciate your work, so that we can achieve. I hope this is a successful one, and we will be achieving next year better publication, product and generation of material will be better next year. Thank you. Thank you very much.
Thank you, Dr. Pradhan. Very nice comments which you have concluded all the 2 days discussion. But in fact, as he rightly pointed out, we had marathon discussion under the chairmanship of Dr. Pradhan to streamline the whole program. That's how we are working now in different AICRPs, and our ADG colleagues, they are taking personal interest in refining the programs which you are executing at different places. So now we are at the end of this whole session, and it's my turn to conclude it. I won't like to say much. I have already said during inaugural session, but 6 quick points which I would like to make here to conclude this session. As Dr. Pradhan pointed out, that we have online meeting. Okay, so my point number 1 is that the purpose of this physical meeting is to have more interaction among the participants, those who are working at different sectors. Otherwise, you have seen that during Corona period, we did all the meetings online and completed this whole exercise. So here, you should interact with your partners and try to solve small problems which you are facing in the execution of your experiments. And you can also develop joint proposals for funding from different agencies. You can find partners of common interest, common areas, and then write proposals for funding on the similar aspect. The second point which I would like to say here is that sharing of resources is very, very important, and we should very clearly define how we are going to share the material or derivatives developed through pre-breeding approach or lines, and also advanced breeding lines. 2 different centers for phenotyping across locations. Besides that, selection of parental lines for involving in crossing programs should also be defined very clearly with the help of experts or PMC members and also other colleagues during discussions that which should be the donor for X trait or Y trait and which variety we should take for as a recipient lines. So all those clarity should come on paper from this workshop. My third point is regarding development of database of whole AICRP data which we are collecting, whether it is related to plant breeding, agronomy, or plant pathology or entomology. There should be a database which is located at ACRIP centers, Hyderabad, so that if somebody is leaving this group or joining some other crops, at least the data is with us, we can continue from there. So I am sure that next year when we come here, there should be some presentation on database development by the computer specialist which you have at your institute, and he can be involved as one of the partners in this particular AICR. The fourth point is related to strong collaboration with CG centers. We had very interesting and excellent presentation by our colleague from ICRISAT. But of late we have seen that there is some sort of disconnect between CG centers and our crop-based institute. Rightly pointed out by Dr. Madhusudan during the interaction. And I also see not only from ICRISAT, from also other CG centers, because all these 6-7 CG centers including IRI, CIMET, then Biodiversity International, ICARDA, that all comes under crop science division. So we are interacting twice in a year, and I have seen that whatever is committed in their work plan, somehow it's missing from the outcome. So in future what we would like to see that all our crop-based institutes, those who are collaborating with CG Center, they can have meetings and also involve their DG. I will request Director Dr. Tara Satyavati to write to the DG of ICRISAT for material exchange and also regarding the program which they are directly executing through our universities. Under the Memorandum of Understanding with CG Center and ICAR, they are not supposed to do that. They have to inform our coordinating unit and our crop-based institutions. So that interaction is, I think, somewhere it's lacking and needs strong collaboration in future. The fifth point is related to finding hotspots for what we call phenotyping for biotic and abiotic stresses. We did a very marathon exercise in case of pulses, where we constituted a committee under the chairmanship of ADG, and PC was the member secretary. By involving experts, 3-4 experts, you identify specific centers which have the facility to phenotype for different diseases or abiotic stresses. And those centers can be strengthened further by giving more funds. So I will request the PC that you constitute a committee within a month's time under the chairmanship of ADG FFC by drawing experts from PNC or from other universities or ICR institutes, and then identify hotspots across the countries which are amongst the participating centers, those who are participating in AICRP experiments, and give them additional money for developing phenotyping facilities. Let me tell you very clearly here that without phenotyping, all sorts of molecular biology and biotechnology which we are doing has no meaning. I'm working on biotechnology for the past 30 years, starting from my PhD till date. And I know very clearly that unless we have a strong phenotypic component and understanding the genetics of or inheritance of a specific trait in those lines, it's very difficult to answer some of the difficult questions which we are now going to face in the future because of global climate change. So the role of these hotspots is becoming more and more important. So try to develop this committee, and I'm sure that you will identify few centers across the country. The last suggestion which I would like to again give to the coordinators, that you should start a practice of awarding certificate to best performing centers. We have this particular system in AICRP of rice and in some other crops, I don't remember now. There we did, if you contact Director Indian Institute of Rice Research, we have developed guidelines on the basis of which the best performing center is identified. And we also took help of PMC members to give their input whether the center is really best performing during that year or not. And during these AICRP meetings, you give appreciation certificate to that particular center. So I'm sure that if you include some different approach in your coordination of all these centers across the country, definitely you are going to get good results. And as very rightly pointed out by Dr. Pradhan, our future is going to be very, very difficult. The type of funding which we are getting, and let me tell you here, all the directors, particularly Dr. Lakshmikant and Dr. Tara Satyavati, and all our directors of ICR 28 institutes knows very well that funding is no problem in crop science division or in ICR. This time we have given extra money to everybody to run their program. So if you have capability to absorb funding from the council, we have enough money for everybody. But we need outcome from their programs. And today is a meeting at 4 p.m. I am really absent today. DC is taking a meeting to present 100 days outcome and 5 years outcome of crop science division, only 2 slides. what we are going to give within 100 days or after 100 days and next 5 years. So my ADV colleague is participating in that meeting in Delhi, and everything is being monitored by PMO. So day by day, it's going to be very, very difficult to get funding, and unless you perform well, no one is going to fund you. Not only I will suggest that you identify the best performing center, but also identify the worst performing centers and eliminate those from this whole program. You can identify some more centers, volunteer center from other universities, and fund those. Those who are not performing need not to carry them along with us. Now we have more than 74 universities across the country, and many people will come forward to join this whole program. So that's what I was interested to share with all of you, and I'm sure that you might have enjoyed these 2 days discussion here. We had very excellent hospitality from the host organization, and I wish you all and also wish you all good luck for your next coming 1 year. And next year when you meet here, I'm sure that you will bring more product in the form of varieties, technologies, publications, or patents. That's what 4 P's are expected from all of you. And I'm sure that you got the message what Council now wants from the top, and will work hard to achieve those targets. So with these words now, I will stop here. Thank you very much for coming over. Thank you.
Thank you very much, sir, for your critical observations and constructive suggestions. We will definitely stand to our expectation, and we assure that we will come up with whatever expectations and anticipations we have put towards us. We will definitely come with them. Before I invite Dr. Sumati for a formal vote of thanks, I, on my behalf and on the behalf of IIMR, ASF, Pearl Millet, sorghum and small millets, I want to acknowledge some of the fine things that have been put forth by the host organization. Really, madam, please convey this to your Vice Chancellor. The hospitality is very, very good. The arrangements are excellent. And moreover, about all these things, with a good expectation of having darshan at Tirumala, many participants have come from all over the country, and you people and your committees and your team have meticulously, I should say meticulously arranged and organized their visit to Tirumala. I know it is very tough to have darshan at Tirumala without a backup support in such a short time. Most of you will be aware about this fact, and this tough part of the entire program was handled meticulously by the university team, and thanks to you, madam, and your entire team. We are really indebted to you in this aspect, and the food, accommodation and everything else is also really good. So I now invite you to give a vote of thanks.
Say good evening to all. This is the end of the 2 days program. I hope it went on well. It's a scientific interactions besides all the other aspects of accommodation, darshan and everything. With these scientific interactions, you might have come to a conclusion point where 6 points has given by our chairperson. Really, sir, it's a very points which are short points which should be done immediately, that will be ready. And let us come to the vote of thanks, because here in the case of the vote of thanks, first let me thank the ICAR, because that is the institute which has made the support to all these ASARP centers of pearl millet, sorghum and other small millets, and thereby through that one, Indian Institute of Millets Research team has supported us to work out this program effectively. Madam and sir, the team of RARS, Regional Agriculture Research Station, SV Agriculture College and Agriculture Research Station Perumalapalli, these three teams worked together to implement this program to a successful end. And I will thank all the people. And let me start with the case of the dignitaries. And I can say, though you are having very busy schedule, sir, as a chief guest, T.R. Sharma, sir, the DDG Crop Science, all the way from Delhi, traveled here. Sir, you spent 2 days successfully to come to a successful end of this workshop. Thank you, sir, from our university, because you are there in our campus. I know shortly you are going to interact with our PG students also. They are waiting for you. And your inspiration will be there with our students also. Then I thank our Honorable Vice Chancellor Madam, distinguished guest for yesterday's inaugural session, because she is the main back support for us to work all the things in a fruitful manner in each and everything. Then I thank the guest of honor of yesterday's inaugural session, S.K. Pradhan sir, ADG. Sir, your support is also what we can say a significant, and your presence is also memorable for us. Then the team members, particularly I have to thank certain people. Those certain people, they need a special thanks. I will refer in the last manner. Then coming to the persons which are made a good number of publications for yesterday's release, because they may have done their support to release for release of that one. And I hope for the next group meeting you may have a more number of publications. I wish all the people to have more number of publications. It may be a credit for you and also for the institute. And I thank the chairmen and team members of different committees, starting from the steering committee of organization, the finance committee, registration committee, stage decoration committee, transport committee, accommodation committee, boarding committee and publicity committee, technical committee, local visit committee, darshan committee I can say, and cultural committee. Because I can't read all the names because of short of time. Really they have done an excellent teamwork where never they had a single remark in any of the committee. I thank all the members of my team members, and Monday again I will conduct a Thanksgiving party for them. Really, madam, actually the Tirupati campus people are well known. We are conducting so many group meetings, seminars, workshops. Probably the persons who are traveling from different corners of the country, one is the attending the scientific forum and another one is the darshan. We made our all efforts to complete that one. By the Lord's grace, that is also a successful. And I can thank the chairmen and co-chairmen of different technical committees. And their presence and their interaction, though I am naming individually, there are different committees. There are, I think, there are totally 7 committees were done. And I thank all the people for their presence and chairing the session and giving the important points in the plenary sessions. Then there is a special thanks are extended for the special guest lecture. I know the Ishwari talk is doing a very good work, and when compared to basic science, we need the frontier technologies. That frontier technology science which was there, which may be a very good support for the case of the future research, that is the one he can make use of the support of the Dr. Ishwar Reddy. He can help you in a different ways, because already we ARS people of Perumalapalli are in association with him. Then I can extend my thanks to print and electronic media. You might have come across in different newspapers for the past 4 days what is the things which we are discussing, what are the things which are there in the case of each and every session. Really, I thank all the print and electronic people for a good coverage and having this workshop to a national level with a good publicity. Then I thank the non-teaching staff and other persons of the university team and farm workers, the logistic workers of drivers and other things, and a special thank to students, because students are the one where yesterday they participated in the cultural program, and a special thanks are there for them. Then my thanks, especially from heartful thanks, are there for all the delegates. Though we made all arrangements, if the people are not there in their seats like this, we may not conduct the things properly. I extend my thanks to all the delegates who travelled and participated here continuously from yesterday to till time. Then I thank the SV Veterinary University because they provided this infrastructure of auditorium and all other things for their things, and also some of the infrastructure provided by SV Agriculture College and also RS people. And special thanks I will extend to the sponsors, because there you will come across one board where they have listed all the sponsors. They have contributed something. It may be a cash or kind or anything for successful completion of this one. Then I extend my special thanks to Dr. C. Ramana Garu, because he is the Associate Director of Research. Recently, only 1 week, last Friday, I have taken charge as an Associate Director of Research. Previously, Dr. C. Ramana Garu, a well-known agricultural engineer, is there in that post. He has worked and framed everything, ground level work he has completed. Only final I have entered and have completed this one. And special thanks are there to Dr. C. Ramana Garu. Then let us come to the persons who are really in the case of this Thanksgiving. One is the Dr. T. Sara Satyavati Madam. Madam, thank you very much for choosing this place to conduct this one, and also continuous support. Whenever I used to ask anything continually by phone or anything, she is responding, guiding the other teamwork members to have the thing. Madam, I hope this collaborative work may extend in future days also, so that it will be well done. It may be going to fruitful in different things for both your institute and also our institute. Then special thanks are there to Dr. Masuda. Sir, I know he is very a leader, I can say, continuously is there in touch with the case of these things and making all the arrangements from time to time. Then another person is the Das. I.K. Das sir also is there in collaboration. I think they have visited thrice or 4 times this campus. They went around all the things. They decided where to conduct meetings, in which manner, in which schedule. Then special thanks are there to Srinivas Babu sir. Sir, thank you sir, because your strong hand supported us to complete the darshan. So special thanks, many thanks are there sir. You can also clap Srinivas Babu sir for a very good support extended. Then I can extend my thanks to Stanley, Malati and Swarna, other team. Really they have done a very good job in the case of anchoring. And there are certain things which will I may miss some people, those who worked in this one directly or indirectly. Anyway, if I will miss anything, anybody, it's not intentional. That's why again I extending my thanks to all the members, so that I hope your journey, back journey will be safe and memorable. Let us hope, and we will have again we will meet sometime with the same intention and with same enthusiasm in the future days. Thank you once again, madam. And yes, please, I ask all the people to stand up for our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I request all the PAs of Sorghum, Pearl Millet and Small Millet, please come to the dais for a group photo with DDG sir and DDG. PAs of all Sorghum, Small, Jaldi, quick, Sorghum, Pearl Millet and Small Millet. Please come quickly. Please hurry up.
Please closer. Please closer. Please closer. Please closer.
Tea and snacks are ready. People who are dispersing can go and take. And night dinner is also arranged by our organizers. So the delegates who are staying are requested to take their dinners also in the same venue.
Delayed interest. Chalo. అవసరంలా ఉండరా ఒక్క రోజు లైట్ లాగరా వైట్ లాగరా ఏమిరా నువ్వు వైట్ లైట్ లాగరా
The delegates present here can go and take the tea and snacks which is arranged, and the dinner is also arranged for today, and the delegates who are staying may please go and take dinner also at the dinner time.
సార్ ఇంక్లోజ్ చేసేసేదా చేసుకో ఓకే సార్